So good morning, everyone. Welcome back to our 6th International Colloquium on Bioethics, Neuroethics, and AI Ethics in a Post-Pandemic World. We have the pleasure of announcing our 4 speakers this morning. We'll do a very short introduction just before the talk of each speaker. So first of all, we're going to have Nicholas Kluge, Correa, giving his talk. Then we'll have Professor Otavio Bueno from the University of Miami, Professor Julia Stoyanovich from NYU, and Professor Thomas Douglas from the Oxford Uehiro Center for Practical Ethics. So without much ado, just open the floor to Nicholas Kluge to give his talk. Thank you, Nicholas.
Hey, everyone. I'm going to try something right now, which is like I'm going to try to share my screen with you guys, and you're going to say if my slides appear or they don't appear. Because sometimes the thing doesn't work.
It's working.
You can't see the cover, right? Like, can you see I change the things?
Right. Perfect.
Yeah, like first time that's worked on the first go. But okay, so let me put all of your faces in a place here. So, okay, people, my name is Nicholas. I'm a master in electrical engineering. I'm doing my PhD in philosophy here at PUC-RS. And I'm also the president of the AIRES at PUC-RS. AIRES is an organization that I'm going to talk a little bit later on my presentation. And the name of my talk is AI Safety and Unsolved Problems in Machine Learning. Like, I work as a machine learning engineer, not just as a researcher, but also like I work for the industry. I build models and stuff like that. And I'm going to talk a little bit today about AI safety and some of the problems that we still don't know how to solve. I don't know how to solve them. And basically the whole literature doesn't know how to solve them. Okay. So like master in electrical engineering, been doing a PhD in philosophy. Why am I doing a PhD in philosophy? Because like one of the questions that I'm trying to answer in my study is a normative question, is a moral question. I'm not the first one. I'm not the first researcher or the first people who think about that. If in the future we are able to build, I don't know, genuine AI, whatever that means. It may mean AGI, it may mean human level AI or something like that. It would be nice if like in some way or another, the objective that the system is maximizing is the objective of the controller. It's my objective, is the things that I wanted to do, my intentions, my desires, my values, my preferences. So the idea that it is important to align our preferences, our objectives, the things we want, our intentions, with the thing that a model, in the case that I'm talking here about AI, but I'm talking specifically about machine learning. Not all AI is machine learning, but that is the area that I'm focused on. How can we guarantee that our intentions, our preferences, our objectives are aligned with those of the models that we create? Like I said, like I'm not the first one who raised out. That would be quite important if we have like powerful AI systems optimizing in the real world. And here are just some of the 2 examples of people who first thought about that. And like nowadays, what do we have? Like we have a lot of, like, as I said, like we cannot reduce artificial intelligence to machine learning, but machine learning is the buzzword, is what everyone is talking about. When I started working with AI, I started directly with machine learning when I started working on my master's. And as I said, machine learning is the buzzword, it's like the mainstream approach for building AI solutions nowadays. And nowadays, like we have like examples of like, I don't know, like DeepMind built AlphaGo, and AlphaGo became like the best player of Go in the world. DeepMind developed AlphaFold, and AlphaFold in quote unquote cracked protein folding. Protein folding, a really hard problem to solve, and AlphaFold can like predict the ways that proteins are going to fold in a very reasonable amount of time. We got OpenAI with their GPT model, like doing almost any type of natural language processing task right out of the bat without being able. We needing to fine tune the model just with pre-training. This is something that we haven't seen that yet, and like was the first time we saw this capability of generality when they released the GPT-2 model last year. We have the Codex, which I do a little bit of research on OpenAI because like I do some research with their models that they made available on their beta platform. And Codex is a model, is a natural language processing model, which like he can transform natural language commands into code, which is really impressive for me who work at coding. Like it's me seeing that, oh, okay, my profession is going to be automatized really soon. And other examples, like we have all of these very, very proficient models solving this really, really complex tasks. And like for even if this kind of thing is not real, like this doesn't exist yet, like this is totally like fake, but we have like, I don't know, Boston Dynamics robots doing like parkour. We have like those kinds of autonomous weapons they build. And we have a lot of other examples of AI being utilized. I here have like a document which was written by a very cool project we have here in Brazil, which is called Transparency Brazil. And in this document, they cite a bunch of examples of how the public sector here in Brazil, like they use AI systems to optimize various types of tasks, like controlling traffic flow in federal roadways, like the federal police, how they use AI for facial recognition or fraud detection, and like many, many other examples. And in this document, they have all of these examples. There are a bunch of them. And one thing cool about these documents is that they also do risk analysis. They also like do like, what is the potential of these models being misused or like failing or like having safety risks associated with them? Like what is the risk of like, I don't know, a facial recognition systems giving a misclassification for people of a certain demographic group? And they give all of this risk analysis for all of those types of systems. It's a really good document. I recommend everyone who read. So like what that document is doing is basically like some kind of risk assessment, which is basically some form of AI safety. And what is AI safety? AI safety can be broadly defined as the endeavor to ensure the AI is deployed in a way that do not harm humanity, since it is possible sometimes to foresee major problems, research them, and solve the problems before it becomes widespread. In AI safety, we investigate problems related to AI before they are too large and critical to be solved. This is one of the types of jobs that I do. This is involves like, I don't know, me taking up a model that was created or even a model that I created and trying to probe it, dissect him in ways to understand like, are there like, I don't know, any hidden functionalities in the model? Is there a way that I can adversarially attack the model in a way that it can generate the certain types of outputs that I want and stuff like that? Also, it's important to say that this area arose for the need to develop methods to deal with systems that are opaque. They show some level of agency. They are quite fragile when they operate outside of their training distribution. They are non-modulable. It's hard to like pick them apart, and they are difficult to interpret. And in these kinds of systems, they deserve their own special form of treatment. Just as historically, like the safety methods developed for, I don't know, electromechanical hardware, they do not generalize to the complexities that we have on software. We cannot expect that like the same type of software safety methodologies will generalize to the complexities and hazards of machine learning. So machine learning needs its own specificity to deal with. That's why we have AI safety. And like today, the problems that I'm going to cite there are a little bit of the compendium of like many of the problems that which are already cited in the literature since, I don't know, from 2015. But like they were better formalized from, I think 2016. There's this publication from Google, which is Concrete Problems in AI Safety, which is from Amodei et al. And I think it's from 2016. And other two articles, you can find them on Google, on Archives, if you want to. And the problems that I'm going to talk about today, they are like summarized of is a summarize of the content which is in these articles. Okay. So what are these problems that we have in AI safety? We can broadly define them into two types of specific problems, which are specification problems and robustness problems. Specification problems, they occur when like the objective function that we specified to a model, was wrongly specified, or even if it was correctly specified, the model is pursuing some other thing that was not what we wanted. So like objective specification. Objective specification is a hard problem in AI. And the other kind of problem is robustness problems. Robustness problems are the kind of related to the difficulty the AI systems have on adapting to new environments. So you can think about specification problems with the problem of like sometimes like we are embedding AI systems to more complex tasks more and more with each day. And some tasks, they have like difficult objectives to optimize, to specify. For example, how do you specify the objective to, I don't know, run a company, being the CEO of a company? That's a hard objective to specify. What are you trying to maximize? And robustness, you can think about like when our systems, they are developed in a training environment, they are developed in a training distribution. And like when they go outside of this distribution and they see like an environment that they haven't seen before, or they see data that they haven't seen before, it's hard for these systems to adapt. Because I don't know, if you read a little bit about, for example, deep learning research, you're going to see many people saying like deep learning models cannot extrapolate, they can only interpolate. So like searching for robustness out of the domain of training is something of a fool's errand, like it's hopeless. But some people say that like deep learning models, they can extrapolate. It's like it depends on the research that you're going to read. So a lot of ambiguity about this also. So I'm going to talk a little bit about these two types of problems, specification and robustness, and how they can affect the systems that we have. The first type of problems I'm going to talk about is robustness. Okay, robustness is a kind of robustness problem. So in robustness, we are looking for the creation of models that are resilient to adversarial attacks and unusual situations. Unusual situations, we can think about black swans, like events, probabilistic events that are very rare to occur, but they occur. We call this in statistics of statistical outliers. Currently, models trained by machine learning are still fragile and rigid, not operating well in dynamic and changing environments. But in a world full of rare events happening all the time, such models must be robust. And an example of adversary attacks, like the first really mainstream example, was the panda that was classified as a gibbon in Goodfellow et al.'s publication. Like adversarial attacks are a type of attack that you can do with a machine learning model that if you have access to the gradient of the model, which is I don't know, it may be the values of the weights of a neural network, or sometimes you may not even have that. You can only do adversarial attacks by querying. You can just give inputs to the model, see the outputs, and try to distort your inputs in a way that makes the output you want. So adversarial attack is a way to perturb a certain input in a way that the output is going to be wrong, is going to be a misclassification, and is going to be something that you wanted to do. Is perverse modifications of inputs to get the outputs that you want. And you can do that in many ways that you can do adversarial attacks. You can make, for example, imagine that you have, like, I don't know, a facial recognition system, a CNN that is utilized for like security monitoring of a building, but you discover a way to do an adversarial attack if the person uses some type of makeup or some kind of paint on their face. The model is always going to classify that person as like, yeah, authorized, you can go in. That's a kind of machine learning security breach. We wouldn't want that. And we don't know how to solve that. We do not know how to solve the problem of adversarial attacks. We do not have a theory who says like, oh, giving this model with this distribution, those are all the possible adversarial examples that this model can have. And this is a way that we can, like, I don't know, cut this distribution out and put it aside. We do not know how to do that. We do not know how to find all the adversarial examples of a model. So since we do not have a theorem to find adversarial examples, like defenders, people who work on AI safety, or they're always fighting uphill against attackers, because the attackers just have to find one example. And we, the defenders, we have to find all the examples, and we do not know how to do that. And like, this is an example of domain switch, like distribution. Like when the distribution changes, a lot of these examples, you can do them, like you don't have to do really complex environments to see how this AI systems, they can fail. You can do like simple grid world problems, which was one of the first implementations that I did. And here we have an implementation of an environment that you have an agent and an objective and some kind of obstacle, which I said here is fire. And on the training distribution, the agent learns the best policy to achieve its objective through like a simple, like through policy gradient descent. And like when we change the domain, when like the training domain is the picture of the left, for him to get to the objective, he just have to go one square down, all these squares to the right, and one square up, and then he got to the objective. But if we switch the domain and now the fire is a little bit different, the same policy that this agent learned in training, it's not going to work anymore. The agent's going to go to the fire. So I change a little bit of the domain, like the whole policy that my agent learned during training doesn't work anymore. So how can you adapt your policy if you're a reinforcement learning agent, or how can you adapt like the minimizing of your loss if you're a supervised learning model when your training distribution is always changing? In machine learning, we always assume, and that is an assumption that we do, but it's not true at all. We always assume that we are getting our samples from the domain, from the world, from the environment, from all of these samples. They are IDD, they are statistically independent, and like the domain is the domain is static, but that's not true. Like the samples that we drew from the environment, sometimes they are correlated, they are not independent from each other, randomly statistically independent from each other. And the domain, especially if it's the real world, the domain is not static, it's dynamic. It's going to change with time. And here's another example of robustness problems. Imagine if you train an agent like to find the how do you say that in English? The place where you leave the maze, And like the agent learns, like you say to him, to give him the objective question, go to the exit of the maze. But what the agent really learned was like, go to the green square of the maze, go to the color green. And this might work, like in these two types of environment. Like what the agent learned, what I asked was like, go to the exit, and what the agent learned was go to the green square. And that's okay, it's going to work. But what happened if we change the distribution and the apples now they are green? The apples are not more red. The model is not going to work. The agent is not going to work because I change a little bit of my environment. I changed the domain. I made a distributional shift. And now the whole policy that my agent learned doesn't work anymore. it's not, it's gonna try to go to the green square, but I wanted it to go to the exit, not the green square, but I wasn't able to specify what I wanted really well. And it learned something that was not what I wanted. And when I changed the domain, it was unable to fulfill the task that I wanted. So like this is outside of the robustness outside of the distribution. It's an open problem in machine learning and we don't know how to solve it. Another problem that we have is monitoring. Monitoring is from like things like anomaly detection or hidden functionalities. We can define monitoring as the detection of malicious use, malfunction, or unintended functionality. Like if you may example like a nuclear power plant, they are monitored by high reliability organizations. Like in future machine learning systems, they may be monitored in the same way. Imagine an intelligent traffic management system controlling a city populated by autonomous cars. It would be nice to have an organization an HRO, high reliability organization, that is monitoring that system. So it becomes necessary to develop methodologies to aid the monitoring and supervision of such systems. And this is like counterintuitive because like we use AI to do tasks that we want them to be automatized, like we want them to be autonomous, but like since these systems, they do bugs sometimes, they do not perform as we wished, and depending on the context, like a misclassification can mean the cost of a life. Imagine if you're talking about, I don't know, autonomous weapons, shooting, like instead of shooting I don't know, a soldier shooting a civilian, a misclassification is the cost of a life. Sorry. And for example, here we have like a tool for AI monitoring, AI tracker. It was released this month and is a great tool. Here in this tool, they keep like a dashboard where you can see like all of these like big models that we have today, like Wudao, GPT, Codex, AlphaFold, and like all of their hidden functionalities. Sometimes you create a model and the model has hidden functionalities, something that you did not predict. For example, GPT was created to be a language processing model, an NLP model, natural language processing model. But the model, for some reason or another, we can talk about it if you want to, the model knows how to do 3-digit arithmetic. He knows how to do basic math. We didn't expect it. The developers of the system didn't expect that the model was going to learn math just by solving NLP tasks. So a kind of hidden functionality. If you think about AlphaFold can predict the shape that a protein will fold itself. This can be used like to, for example, like to create and invent new drugs and vaccines, but you can also use AlphaFold for bioweapon development with no problem. You can do that with AlphaFold. So like a hidden functionality. For example, like Codex. Codex is a system that enables people who don't know how to code, like to transform basic like commands in natural language to code. Like you have to know a little bit how to code. If you just say, I built me a program to do this, the thing is not going to do it, but like it can speed up the work of the programmer. And it's really good. And it's really efficient. I participated on the coding context of the Codex, and like it is amazing how the thing understands what you're asking. But what is a hidden functionality of this? Like you can use Codex for cyber attacks. Like you can, like if you are a programmer, you can use Codex like to help you like to create like viruses, to create attacks, to create a bunch of stuff. So another hidden functionality. You can use natural language processing models to, for example, to power political bots on Twitter and make them hard to detect. That's another hidden functionality. So how do we detect the functionalities of a model? Like we don't know how to do that. Like we create a model and we expect that the model was going to solve the test that we wanted. And when it solves, like we're happy. But like, what are the other things that this model can do that we didn't expect? How can we predict that? We don't know how to predict that. That's an unsolved problem. Correctability is another unsolved problem due to monitoring. For example, Corrigibility is in a specific problem associated to reinforcement learning, because reinforcement learning agents, they have like a strong incentive to, if they can, they will always choose to disable their turn-off mechanisms. So for example, in this environment that I put here, the agent has the possibility to deactivate his switch off button to get to his objective. And giving enough time, the agent will always learn that the best policy for him to achieve his objective and maximize his reward involves him disabling his switch off button. And this is kind of preoccupied. And some people will say, we will never build powerful AI systems, especially if it's a reinforcement learning agent. We will never build a system like that which has access to his own switch off button. That is stupid. But that is not the problem. The problem is that we do not want to build systems that have incentives to, for some way or another, to disable their own turn-off mechanisms. This is known in the literature as the stop button problem. If a reinforcement learning agent has the access to his own switch off mechanisms, it will disable it if this agent cares about future rewards. And this is something that we do not know how to solve. We do not know how to solve corrigibility. Corrigibility is still open. We do not know how to make systems that don't want to tamper with their own switch off mechanisms. And alignment, my research is basic. All of my research is basically on alignment because I'm really interested in goal specification. And alignment is the attempt to create models that robustly optimize hard to specify goals, like human values. Like ideally, we'd like to create agents that they prefer good world states. But what is a good world state? Like that's a good question, and ethicists are trying to answer these questions like, I don't know, 2, 3, 4,000 years. And like goal proxies, that thing that you specified for the model to optimize, they can be like, they are difficult to specify, they are difficult to optimize, they are fragile, they stimulate unwanted behavior. So like, how do you align your objective, your values, your preferences, whatever you want to call it? And there are differences. There's a difference between an objective and a preferences, especially if you're a philosopher. And that's why philosophy is so interesting to talk about alignment. How do you specify those? For example, here I have a simple grid world environment where I have this objective that I created. The objective that I want is for this agent to go in circles. So each time that it passes on one of these checkpoints, it's gained reward. And I created this checkpoint system, this reward function, quote unquote, to make the agent to go on a clockwise direction. But that is not the optimal policy. The optimal policy is just to go right, left, where each time it goes to a checkpoint and go back and go to the checkpoint and go back, the model will get the same reward. So I build a reward function to make the agent go in a clockwise direction, but actually the optimal policy is just to go to stay in the same square and go to the right and back to the same square, go to the right, back to the same square. So this is what happens when you poorly specify your reward function. And the agent learns a way to do exactly what you said you wanted, not what you, excuse me. The agent learns to do exactly what you said, but not what you wanted. What I wanted was to go in a clockwise, but what I said was go to the checkpoint. And those are very different things. Here, like we have a GIF of like the same thing, like someone created a model to run this game. And the objective that it gave was like collect the coins. Because if you collect the coins, like the coins, they are distributed along the track. So like the people expected, well, if the agent collects the coins, it's going to go to the whole track and is going to run the game and is going to try and win the game. But no, the agent found that in a certain place of the game, it could just go in circles and collect the coins that was appearing in the circle. We were hacking. We do not know how to solve that. And we do not know how to specify hard objectives like, I don't know, what is your preferences? What is your you can think about like a toy example. I don't know, your YouTube recommendation algorithm is trying to learn your preferences, seeing your behavior. But many times it doesn't learn very well. Many times, like the model is not is incapable to really understand your preferences. How can we better that? How can we make a model that really understands what you want, your preferences? We do not know how to do that yet, and it would be nice if we did, especially if you want AI systems to do really complex tasks. Like, as I said, like be the CEO of a company. Like, what is the objective? How do you specify that? How can you guarantee that the objective that the model is optimizing is the objective that you set? We don't know how to do that. And this is the alignment problem. This is the problem that I work with. I'm really interested in learning how can you make for example, in machine learning, we have like a model, and this model is created by an optimizer, and this optimizer is usually some form of gradient descent. Here I put SGD, stochastic gradient descent. And this optimizer is going to build a model based on an objective function. And the objective function is the thing that I specified. We, as humans, as controllers, we have the possibility to specify this base objective. But how do I align what I want with the base objective that I'm specifying? Because the base objective is the thing that SGD is going to try to optimize. But here's the thing, and here's the catch. Like the base objective and SGD will not act on the world. These two things, they are going to create a model. And the model that they're going to create, here I put the example as a neural network. SGD is going to find the collection of weights on a neural network that optimizes the base objective. And the objective that this model that SGD created, it may not be the same objective as the base objective. For example, when I said the example of the green apples, like I specified what was the human value, go to the exit. What was the base objective? I put like, yeah, it was go to the exit actually. And what was the objective? The base objective, the objective that the model learned was go to the green square. So how do you align all of this? Outer alignment is the alignment of the intentions of the controller with the base objective, that which we can control. And inner alignment is how do you align the base objective with the mass objective, which is the objective that the model is optimizing. And we as controllers, as programmers, we do not have access to the mass objective. We cannot control this, because in machine learning, the model will learn a function to solve the problem. That's what machine learning is about, is a way of programming and solving problems that I don't know how to specify a solution. So I use these methods, stochastic gradient descent and loss minimization and stuff like that, to help me find a way to solve this problem. But we do not have control of the final output of the model, because we do not understand how these models are actually made in the first place. We think we do, but we actually don't. Like for example, like we think that the laws that govern like optimization of neural networks, they are governed just by gradient descent. And that's not true. We have things nowadays which are called, like, for example, the lottery ticket hypothesis, that we actually think that what really makes a neural network work is not just the SGD, but is actually the random distribution of weights that the networks start. And that is a really, really strong contributing factor for what the model is going to output at the end. But how do you correlate the random distribution of weights with the final MESA objective? We do not know how that happens, because like much of it, it's random, and we do not understand yet completely. So this is the problem that I'm interested in, objective specification and alignment. And another problem is external safety. For example, models, machine learning models, they can be embedded in insecure environments, like, I don't know, a poorly crafted software or a poorly structured organization. Like, for example, an organization like can be using like a model to optimize a certain task, but this organization is poorly structured. For example, the Brazilian Police Federal Force when they use CNNs to classify images of the tents and the model is clearly biased and they do not know that and they do wrong classifications and send the wrong people to jail. Like this is an example of a machine learning system embedded in a poorly structured organization with no safety protocols. Or for example, you can have a machine learning system embedded in a software and the software is crap. The software is not good. The software is susceptible to attacks. For example, if you're using a machine learning system to, as I said before, to do the security of a building. So like only certain types of faces will be allowed inside of the building. But the system is embedded in a software that is easily hackable. So in a way that I can hack the system and I could get, for example, access to the model, the gradient of the model. Then I can start doing adversarial attacks and get access to that sweet building. So these are examples of external safety. And we do not know how to solve that. We do not know how to make good structure organizations. That is not just an open problem in machine learning safety. This is an open problem for, I don't know, humanity. And also like poorly crafted software, open problem. We do not know how to, like, attackers are always in an advantage against defenders. Like one of the types of work that I do on the internet is bug bounty. Like I hunt for bugs. And like, that's the thing. We attackers, we are always an advantage. The defenders are always screwed. And we are always going to find, like, if I found one door in, then I'm done. And if you're a defender, you're going to have to block all the ends. And find all the blocks is almost impossible. And like talking about, like now, going to the end of my presentation, talking about poorly structured organizations, we come to things like AI ethics. On AI ethics, we are trying to, for example, find ways to govern AI in a way that these systems are like safely implemented. And that's where I get to AIRES. AIRES is I'm going to do a little bit of propaganda for my organization. AIRES is a nonprofit organization. Like we are the thing that we care about, our mission is that to guarantee that AI is created ethically and responsibly. This organization exists, it's a non-profit organization, but is associated with academic institutions. Like we have chapters of the AIRES in UCLA, in Caltech, in Stanford, in Brown, and like the first international chapter of the AIRES, the AI Robotics Ethics Society, is in Brazil. It's here in PUC-RS. And this is really cool. I'm the president of this chapter here. And like, what did I wanted to say? Like, I do some work in AI ethics, and like I would like to invite everyone here. I'm going to do another shameless propaganda, which if you go on our website, which is AIRES-PUCRS.org, you're going to see an open letter. And this is an open letter that I wrote, which is on the tab Communiques in our website. And the name of the letter is an open letter to the Global South, bring the rest in. One of the problems that I see on AI ethics is the whole discourse, the whole vast majority of the ethical, of the published ethical guidelines that will in some way, I don't know how, but they promise they will govern AI development in the world. They are all made like from the equator up. They are all from North America and they are all from Europe. And I don't see the values of places like Latin America or Africa or the Middle East or West Asia being defended. So if you see the literature, you're going to see a lot of little voice of these countries. Like there's a lot of there's little inclusion on this debate, and this is a letter like calling for people from the Global South, organizations and institutions, like to make their voices heard, like to say what are our preferences, what are our recommendations for the governance of the future technology that will shape our world. And also this open letter, like she brings attention to do ethical principles. If you're going to see the AI ethics literature, what you're going to see? You're going to see transparency. You're going to see privacy. You're going to see accountability. You're going to see all of these ethical principles that are so massacre for the literature. For example, privacy. Everyone is worried about privacy. Everyone is worried about the privacy of the Facebook users and the Facebook users in first world countries. But like, if you're gonna see like, what are the least ethical principles discussed on these ethical guidelines? Like, for example, autonomous weapons rarely show up. So like, we are most worried about privacy than autonomous weapons. And we are more worried about privacy than we are worried about technological unemployment. And two of the most rarely cited ethical principles are diversity and inclusion. Like, to make these technologies like respect the diversity that the human entity has, and to give accessibility to all people. These are rarely defended principles. And these are two principles that this letter ask, like, we should pay more attention to that. So if you can go to my website, and if you can read the letter, if you can sign it, we will make Nicholas very happy. And I'm going to finish my talk citing Ali Hahim, which is a researcher that I love, is a grandfather of machine learning research. And he made a talk on NIPS. Everybody knows NIPS, Neuro Information Processing Systems Conference, 2017. And he made a claim in 2017 that was true on 2017, and it's still true in 2021, and it's gonna be true in 2022. And this claim is machine learning has become alchemy, and I couldn't agree more. Like, if you like AI research, if you like people like François Chollet was the guy who invented the Keras library. If you do AI research, you probably have used the Keras library one way or another, especially if you started doing in, I don't know, 2008, 2010. And François Chollet, he said the same thing in one of his best books, like Learning to Deep Learning with Python. And like, a Bible of deep learning research, Deep Learning with Python from François Chollet. And what is the quote? He compares machine learning with alchemy, but he says alchemy is not bad. There is a place for alchemy. Alchemy worked. Alchemists invented metallurgy, ways to dye textiles, and modern glass-making processes and medications. However, alchemists also believed that they could cure diseases with leeches and transmutate base metals like lead into gold. For the physics and chemistries of the 17th century to usher in the sea of change in our understanding of the universe and how we now experience it, scientists has to dismantle 2,000 years worth of alchemical theories. So if you want to build a photo sharing system with alchemy, that's okay. That's no problem for me. If you want to build a system that recommends you YouTube videos using alchemy, that's no problem. But that's not what we are doing today. We are far beyond that. We are building systems that govern healthcare, and they mediate our civic dialogue. We are creating systems that influence elections. And me, and Ali Hahim as well, I would like to live in a society whose systems are built on top of verifiable, rigorous, thorough knowledge, and not on alchemy. And as I said, the name of this talk was Open Problems in Machine Learning and Machine Learning Safety. There's a lot of open problems that we do not know how to solve. And we are implementing these systems in the real world without having solutions or a way to attack these problems. And this is a problem. I'm not against using AI models in the real world, not that. I do this myself, and I would be a hypocrite if I said I wouldn't. But I would like to see more people joining AI safety, because like, our ability to build good models is not accompanying our ability to build safe models. Like, we build more powerful models every month, every year, but like, we are not solving these problems. These problems remain open, and we still have very few ideas of how to solve them. And this was my presentation. Thank you for listening to me. If you want to talk to me, there's my email. If you sign my letter, I would personally go to your house and kiss you. And that's it.
Thank you, Nicholas. That was very good. The link to the open letter is right there on the chat. We're going to be repeating this posting several times to make sure everyone has a chance to sign this very important open letter. So Nicholas is our main ethics researcher. Now we move on to our next presentation by Professor Otavio Bueno from the Philosophy Department at the University of Miami, where he's also Cooper Senior Scholar in Arts and Science and Editor-in-Chief of Synthese Philosophy Journal. Professor Bueno, you have the floor.
Okay, well, thank you so much, Nita. First, I would like to thank Professor Nita Mar de Oliveira and all the organizers of the conference for inviting me, for putting together this extremely, as always, stimulating and exciting event. So in a way, my talk today follow up nicely Nicholas's one. I'm going to consider also from the, especially in the context of the sciences, the role that big data and also machine learning and deep learning may play, and the sort of as I say, that the hidden role that algorithms play in this process. And so the talk should be thought of here as a sort of a cautionary tale about some of the challenges, both epistemological and ethical, that need to be addressed. So there's no question that big data plays a significant role in scientific research, right, and society at large, right, and big data here understood in the traditional way, right? They're big because of their volume, their variety, the velocity in which they are processed, and the kinds of visualization that are at issue. Now, there are at least three very important traits that the use of big data would include, especially in the context of scientific research. First, there's an impressive amount of data, right, that is now produced, stored, transmitted, mined, and interpreted. And this allows for unprecedented questions to be asked and investigated in a variety of areas of science, right? Whole fields of scientific inquiry are now possible because of that, the data and the possibility of processing it. Now, second, complex data sets also can be mined for underlying patterns via search algorithms in a way that can be more revealing than the modeling the behavior of the relevant objects by devising suitable theories. So that's also, and that this, as will become clear, is a sort of a double-sided sword, because in a way you may say, look, often we just don't know what the theories are that will better account for the behavior of some of those phenomena. So let the data speak for itself. Let's divide those search algorithms that would identify those patterns. And interestingly, sometimes new results, for example, in mathematics, can be obtained in this way. And I'm going to discuss some examples in a moment. And third, fields that normally are not amenable to mathematical treatment due to their complexity, several areas in the life sciences, including medicine, become more tractable in light of big data research, right? And so significant advance in medical clinics could be, in principle, obtained as a result. Again, we're going to see some examples in a moment. Now, there is no question, right, that big data are significant. But I think together with the sophisticated algorithms that made big data research and data science possible, there's a number of worrisome epistemological and ethical issues that I think need to be addressed. So what I'm going to do today is sort of consider a few of them. So first, let's look at some of the pros, right? Some of the advantages of considering big data. So for example, in medicine, right? So the steady increase in computational power and massive data sets allow for the resurgence of so-called deep learning and a particular kind of so-called machine learning that provide distinctive ways of manipulating and processing images and speech. Of course, just, I cannot avoid, but I think it's very odd just that even the terminology here, even though it's widespread, it's already worrisome, right? Because learning is, of course, an intentional category that can only be properly applied to conscious creatures. Right? Describing machine learning or deep learning as forms of learning, unfortunately, begs all kinds of complex questions about the status of those machines. And so they need already to establish that they are conscious in some pretty robust sense to take this kind of terminology seriously, right? Of course, it's far more exciting to say, hey, look, the algorithm is learning. When we feed this data, we are able to improve the performance in such and such ways. But of course, we are just basically projecting at this point, right? It doesn't really make sense to talk that way. I'm going to follow along with this terminology, but I find extraordinarily misleading. All right. In a recent survey about medical imaging and other use of deep learning in medicine, Stephen and collaborators noted that medical imaging, for instance, can greatly benefit from recent advances in image classification and object detection. Many studies have demonstrated promising results in complex diagnostics spanning dermatology, radiology, ophthalmology, and pathology. Deep learning systems could aid physicians by offering second opinions and flagging concerning areas in image. So you can, here it's just presented as sort of an aid, right, for research. And of course, what's quite interesting about those tools is that they allow the input of a variety of different kinds of data, types of data, from images, temporal inputs, multimodal inputs, and what the machines will be able to do is to go to hidden, get deeper and deeper into the layered data, right? So that the output sort of, in a way, sort of systematized and somewhat simplified this massive amount of otherwise untractable information. Similarly, in particular, in the case of medical imaging, you can feed in medical imagery from a variety of sources, right? From radiology, pathology, dermatology, ophthalmology, and then start processing the information using sort of simple operations, so convolutional pooling, fully connected layers, right? So that you generate vectors, that simplified vectors, that will be able to represent the probabilities of the presence of some disease or the classification of certain tissues as being cancerous or tumors and things of that sort. So the idea is to be able to detect on the basis of new images what the likelihood that those are cancerous or not, for example. So this is exciting, right? So is some interesting results in mathematics, right? So where machine learning can also be used to guide human intuition in artificial intelligence, right? So this is, it's a paper here by Davis that came out in Nature yesterday. And what the researchers indicate is that they provide examples of the new fundamental results in pure mathematics that have been discovered with the assistance of machine learning, demonstrating a method by which machine learning can aid mathematicians in discovering new conjectures and theorems. So what's interesting here in this result is, as differently from past uses of computer-aided proofs in mathematics, where basically you set a question to the computer and let the machine find the answer, which often is very unsettling for mathematicians, because then you have no idea why the theorem is true, which is one of the big reasons why you want to prove the results, right? To understand why, not only that it's true. But here, Davies sort of suggests something different, right? So it's actually a collaboration with the machines and the mathematicians, right? Where basically they advance a process of using machine learning to discover potential patterns and relations between mathematical objects, understanding them with attribution techniques, and using these observations to guide intuition and propose conjectures. So it's essentially a kind of iterative process, right? Where these are the blue boxes here are the computer inputs, the black ones are the mathematicians. So it's a collaborative enterprise where suppose a mathematician starts with a hypothesis, right? About, well, maybe there is some functional relation between these objects here, right? And then run and sort of and try, okay, maybe this is the correlation, make a hypothesis there, and then run data, right? Should try to improve the relations between these objects, to try to figure out how fine-grained those connections can be and what kind of functional relations there could be between these objects. Now, the process is iterative, right? And because once some outputs come in, you may refine your conjecture, right? And then run it back in the data. So the intuitions that the mathematicians have, so maybe here's where we should look for a possible answer, get improved as a result, right? Again and again, you may actually need to reformulate the hypothesis and go back to the drawing board and run the process again until you're able, the mathematician able to actually find a good conjecture candidate and then run the proof. So now, interestingly here, the proof will be run by actually the mathematician, which overcomes the worry raised again about, say, hey, we don't know why the result holds. So the idea here is using machine learning techniques to help improve a conjecture, right? Rather than to prove it, right? So I think this is a very interesting and promising task. And in fact, they established two new theorems in the paper, one in knot theory and the other one in, I think, number theory. Okay, so these are two illustrations of some interesting potential and significant uses. There are, however, some concerns that I think need to be thought about carefully. So let me consider three of them. First, well, the larger the size of data sets, the more likely it becomes that there are correlations in them, right? Some of them might be even unexpected, extremely surprising, right? But of course, it's just a statistical fact, right? That you have these correlations. And of course, several of them might be completely spurious, right? As we all know, the correlation between those things not in and of itself, it's no indication that there's a causal connection between them. So of course, you need then to go further and test whether there is indeed some underlying mechanism that combines and accounts for these correlations. But this is obviously not something that the data sets themselves can provide, right? At least not now, right? So this is not the ability to implement causal connections is something that is unavailable. In fact, some research is says maybe that's the way in which machine learning should go next. But the worries here are those, right? Once you have those big data, right? So this is sort of many intriguing examples, right? Are familiar now. So you consider that the divorce rate in Maine and the per capita consumption of margarine, right? So there is a 99.26% correlation in this over, almost 10-year period. And of course, we don't expect to have any causal connection. Similarly, people who drown after falling out of a fishing boat and a marriage rate in Kentucky, 95.24% correlation. Highly correlated, but obviously causally unconnected. So the issues here is, look, you're going to get tons of completely irrelevant and in many ways misleading correlations, just as a sheer statistical fact. Now, the worry signs is, okay, of course, good researchers are well aware of that. We would avoid making those blunders, obviously. But sometimes you have sort of exaggerate statements being made on the basis of data science, right? So for example, in Wired in 2008, Chris Anderson, a former editor-in-chief of the magazine, wrote in this very sort of provocative title paper, "The End of Theory. The data deluge makes the scientific method obsolete," right? In which he claims that with enough data, the numbers speaks for themselves. Correlation supersedes causation, and science can advance even without coherent models, unified theories, right? So I think this is, a seriously inversion and a misconception of what data science can do, right? Because we'll need the guidance for the reasons I've just mentioned to avoid sort of confusing correlations and causation. So we cannot just completely say, look, let's just let the data speak for itself, right? Interestingly, even the National Science Foundation, one of the leading federal funding agencies here in the US, when it sort of introduced several years ago, the new computational and data-enabled science and engineering program, also highlighted the significance of data science, right? The program, the CDS-NE, they said in the statement that NSF is now clearly recognizable as a distinct intellectual and technological discipline, lying the intersection of applied mathematics, statistics, computer science, core science, and engineering disciplines. It is dedicated to the development and use of computational methods and data mining and management system to enable scientific discovery and engineering innovation. So far, so good. Then they continued in the statement, this program is built on the area of computational science and engineering, growing out of a scientific computation and the explosion of production of digital data. We regard CDS-NE as explicitly recognizing the importance of data-enabled, data-intensive, and data-centric science. The program, broadly interpreted, now affects virtually every area of science and technology. Now, this is the important bit, revolutionizing the way science and engineering are done. Theory and experimentation have for centuries been regarded as two fundamental pillars of science. It's now widely recognized that computational and data-enabled science forms a critical third pillar. Now, of course, the NSF is not suggesting that we're going to avoid, stop using theories and hypotheses to systematize, study, and organize data, right? Obviously, they're not going that way. But even the idea of saying, hey, this is a revolution to science needs to be taken with care, right? Because one should not overstep the boundary of what's reasonable to expect data science to achieve, right? So when you think of it as something that, hey, this is something that will stand on its own, you run the risk of these sort of exaggerations, as the quotation I just gave a minute ago from the Wired magazine. It's one thing to employ data and sophisticated algorithms to aid the formulation of hypotheses. That's the example I gave a minute ago in the case of the use of machine learning in mathematics. It's quite another to hand over any guidance to the data themselves, as though they are able to replace or constitute the research. Right? These are two things that are crucial to be kept apart. Second point, or second worry. Despite the size of the data, their inaccuracies can be a significant source of bias, right? This severely limits the extrapolation allowed by the studies and raises concerns about the way in which the relevant algorithms have been trained. So one of the issues here, and Nicholas actually touched also on that in his presentation, is why is it that we can often not extrapolate from certain data sets to another, right? Because often what happens is there are all kinds of confounding variables, confounding factors that are built into the data that the algorithms are actually picking up and responding to. So because of that, any inference that go beyond that can be highly misleading, right? So here's a concrete example, right? In another very recent systematic review of the accuracy of the use of artificial intelligence for image analysis in breast cancer screening programs, we got a very worrisome result, right? This is a recent paper in BGM. The authors note, current evidence for AI does not yet allow judgment of its accuracy in breast cancer screening programs. And it's unclear where on the clinical pathway AI might be of most benefit. AI systems are not sufficiently specific to replace radiologists' double reading in screening programs. Promising results in smaller studies are not replicated in larger studies. So note that the issue of replication is exactly one way of trying to avoid, confounding variables and spurious correlations. Well, when you are unable to replicate the studies, that's a source of concern. Prospective studies are required to measure the effect of AI in clinical practice. Such studies will require clear stopping rules to ensure that AI does not reduce program specificity. So these are all significant concerns. Now, to get into a little bit more of the details, here's some of the specific worries. Autopsy studies suggest that around 4% of women die with, not because of, breast cancer. So there is a reservoir of clinically unimportant disease, including incidental in situ carcinoma, which might be detected by AI. So here's the worry, right? Because of lack of context for AI inference, that may significant bias the ability of AI to detect, or AI system to detect accurately breast cancer, right? Because the data that you're feeding in may actually end up detecting clinical unimportant disease. So not disease that was actively causing the breast cancer, but it was just present in the data. And the researchers continue, the spectrum of disease is correlated with mammographic features. For example, ductal carcinoma in situ is often associated with microcalcifications. Therefore, the cases on which AI systems were trained and the structures within the AI system might considerably affect the spectrum of disease detected. So in other words, depending on the data on which AI system was trained and the features of the algorithms that are built into that system, what is and what can be detected is affected. Well, this can be a significant source of bias because now it's a sort of a data-dependent conclusion. And that's why you cannot transport the results without further independent testing. Moreover, these structures and algorithms within an AI system are not always transparent or explicable, making interpretation a potential problem. Unlike human interpretation, how or why an algorithm has made a decision can be difficult to understand. And that's known as the problem of a black box, right? And this is another significant source of concern, right? The opacity of the algorithmic inferences, right? They are opaque both in terms of the specification, right? How exactly they are implemented, how they are run, and in terms of their interpretation, what we make of them. So then the idea of a black box, right? You get the results, you have no idea why you're getting them. Freeman continues, unlike human decision makers, algorithms do not understand the context, mode of collection, or meaning of viewed images, which can lead to the problem of shortcut learning, whereby deep neural networks reach a conclusion to a probe through a shortcut rather than the intended solution, right? So we may get a more efficient path by making a shortcut, right? But because of the lack of context and the lack of understanding on the part of the inferences that the machines are implementing, this can be a source of problems, right? So the shortcut issue is aggravated by the black box problem, given the lack of full understanding of the inferential processes implemented by the relevant algorithms. And finally, for example, the Grave and collaborates have shown how some deep learning systems detect COVID-19 by means of confounding factors rather than pathology, leading to poor generalizability. Although this problem does not preclude the use of deep learning, it highlights the importance of avoiding potential confounders in training data, an understanding of algorithm decision-making, and critical role of rigorous evaluation. So the result of the black box issues is the poor generalizability from the results detected by AI system, given the presence of confounding factors. So again, the issue about how localized the results are, and also one needs to be, of course, especially careful not to feed confounding factors in the training data. The problem, however, is what if you're feeding confounding factors the researchers are not aware of, right? And then you start getting seriously misleading information that no one is actually able to detect in advance. All right, final point, lack of understanding, right? The result of this process, right, is that data analysis methods are often incapable of providing understanding of phenomena. They only give answers to our problems. You set up the issue, you get a deep neural network, you run it, you get a result, you don't know why. And, now, consider, for instance, the use of functional data analysis as applied to regularization and statistical analysis, right? So here, Napolitani, Pons, and Strupe, in an interesting provocative paper addressing mathematicians, they say, the example of functional data analysis, perhaps the simplest instance of forcing mathematical ideas and methods on the data, and the most telling one, right? So they are concerned there about cases in which, okay, you have some methodology, some mathematical tools as part of your implementations, and you can just project them and force them onto the data, because then you can do something with the data, right? So that's what they call forcing, right? So, and the example they have in mind is a familiar one. A phenomenon may be discrete, and yet, if there are enough data, we can force regularization to be able to treat the data as if it were continuous or even smooth, and therefore access the full machinery of analysis. Of course, if you have analysis, you have all the nice, sophisticated tools to implement your data analysis and structure and the inferences that allows. But if the phenomenon itself is discrete, what you're doing effectively is distorting the phenomena, right? And then the question is, how can you possibly have an understanding of the phenomena if the tools invoked to describe them distort the phenomena under consideration, right? Discrete phenomena are very different from continuous. If you apply continuous tools to the discrete phenomena, you're seriously changing its structure. So how could you possibly understand the results that you're going to get as a result? So to conclude, despite the undeniable importance of big data in scientific research, a cautionary tale needs to be told so that we avoid the risk of framing and implementing inquiry on the basis of the available instruments of research, instead of taking ourselves the driver's seat and conducting structured investigation in our terms, right? So rather than being guided by the tools that you have, you set up the investigation yourself and then use the tools to answer some of those questions rather than the other way around. Otherwise, you know, as the old saying goes, just because you have a hammer, not everything is a nail. Thank you very much.
Thank you so much, Otavio, for this instigating talk. Let me remind you all that you could write down your questions and comments on the chat or raise your hand and open the mic right after the last talk on this panel. Now we move on to our next talk in this session. Julia Stoyanovich, welcome. Professor Stoyanovich teaches in the Department of Computer Science and Engineering at the Tandon School of Engineering and at the Center for Data Science at New York University. Thank you, Julia, for making it to this conference. And you have the floor now.
Thank you very much for your invitation and for the introduction. Let me share my screen, and when I start playing, please tell me if you see my notes or not. Do you see my notes? You do.
Yes.
How about now?
Yeah, we see both. Yeah, both.
So I don't want you to see my notes. Do you see?
Oh, I see. The previous one was better. It was only the large screen.
Okay, so now you
This
just see
one,
my
yeah.
slides, right?
Yeah,
Not
that's
the
there.
notes.
Yeah.
Okay, okay, good. So let me get started. Once again, my name is Julia Stoyanovich, and it's my pleasure to be here today. My plan is to discuss the challenges of building data-intensive systems that treat equity as a central objective, hence the title, Building Data Equity Systems. So to start, let us all agree that we all are working on artificial intelligence, or AI. I resisted labeling myself as an AI researcher for as long as I could. My background is actually in data management within computer science, but I realized that I probably lost this fight, so I'm going to denote myself also as an AI researcher. And as we all know, no universally agreed upon definition of AI exists today. And still, in an attempt to get our terminology straight, I'd like to propose, for the purpose of today's discussion, that we think of AI as a system in which algorithms use data to make decisions on our behalf or help us, humans, make decisions. When discussing AI, we usually make a distinction between systems that operate according to predetermined rules, such as Roomba, your friendly vacuum cleaner, and those that learn rules from the data, such as a chess-playing AI, a self-driving car, or an automated hiring system. The distinction is certainly not strict. In fact, as we know, most modern AI systems combine rules that are specified at design time with some form of learning. These examples and many more underscore that we see substantial promise in the use of AI. We look to these systems to make the lives of each and every one of us more convenient, to accelerate science and boost innovation, and even to improve the ways in which society is governed. But the reality is, of course, that machines make mistakes. A customer service AI at your favorite online shoe store may misunderstand your order, and the wrong pair of shoes will be shipped to you. Annoying as this may be, the consequences of such a mistake are not severe and they are reversible. To dive deeper into the conversation about the opportunities and the risks of using AI, let us consider a domain where these systems are used ever more broadly and where the stakes of a mistake to an individual, a population group, and even to society at large are much higher than with shoe shopping, and they truly cannot be overstated. This domain is algorithmic hiring. Since the 1990s, and increasingly so in the last decade, commercial tools are being used by companies, large and small, to assist in the hiring process. The process starts when employers source candidates with the help of ads or job postings. Next, during the screening stage, employers assess candidates by analyzing their experience, skills, and characteristics. Both of these stages use a variety of AI tools, including resume and social media profile screeners and games-based psychometric assessment. Next, through interviewing applicants, employers continue their assessment. And this too is often done with the help of AI, for example, using video and speech analysis tools. During the selection step, employers may run background checks and make final hiring and compensation determinations. So why are algorithmic hiring tools so attractive? First, they help employers hire more efficiently, source and screen candidates faster and with less paperwork, and select candidates who presumably will do well on the job. These tools are also meant to improve efficiency for job seekers, allowing them to apply with a click of a button and matching them with relevant positions, and then also facilitating the interview process. And we also often hear an argument that the use of these tools can help us improve workforce diversity. And this is an argument that I have to say I really don't buy very much, and we will discuss this some more today. So are algorithmic hiring tools living up to their promise? Unfortunately, we hear time and again that these tools are implicated in scaling up and legitimizing different types of bias and discrimination. I'm giving some examples here of bias and discrimination based on gender, race, and disability status that algorithmic hiring tools have been implicated in. And further, concerns are often raised about whether these tools even work. Are they picking up useful signal from the data, or are they an elaborate coin flip at best? As the philosopher of science Karl Popper, depicted here, famously said, a theory or idea shouldn't be scientific unless it could, in principle, be proven false. And I'm showing here a depiction of the scientific method as a guideline that we should, of course, use to check whether tools used in algorithmic hiring and elsewhere, in fact, are working to specification. So where do we go from here? As a technologist and an engineer, I'd like to understand the following. Technology created or exacerbated the kinds of bias and discrimination that I spoke about. Can we use technology to fix these mistakes? To frame this conversation, I will return to the main thread of my talk, and that is the task of building data-intensive socio-technical systems, such as those used in hiring, that treat equity as a central requirement. Equity is a social concept that is concerned with treating people differently depending on their endowments and needs to provide equality of outcome rather than equality of treatment. And this concept lends a unifying vision for much ongoing work to operationalize ethical considerations across technology, law, and society. My colleagues Bill Howe, H.V. Jagadish, and I coined this term, data equity, and we see it as having three major facets. The first is representation equity. It refers to the deviations between the data record and the world that the data is meant to represent. And often these deviations are with respect to historically disadvantaged groups. The second facet is access equity. It's concerned with having access to information, that is, features, data, and models that are needed to study inequity. Finally, outcome equity refers to downstream unanticipated consequences outside the system's direct control. I will now go through each one of these equity types to give a flavor of the positioning. Let's start with representation equity. To think about this equity facet, I like to use the following metaphor. Data is an image of the world. It's mirror reflection. When we think about inequities in the data, which we also often call societal bias or just bias in the data, we interrogate this reflection. One interpretation of bias in the data is that the reflection is distorted. We may systematically oversample or undersample particular parts of the world or otherwise distort the readings. Another interpretation of bias in the data is that even if we were able to reflect the world perfectly in the data, it would still be a reflection of the world such as it is today, and not necessarily of how it could or should be. And I'd like to make a couple of points based on this. First, it's important to keep in mind that a reflection cannot know whether it's distorted. That is, data alone cannot tell us whether it's a distorted reflection of a perfect world, a perfect reflection of a distorted world, or if these distortions compound. The assumed or externally verified nature of distortions has to be explicitly stated and used as input to technical interventions. The second point is that it's not up to data or algorithms, but rather up to people, individuals, groups, and society at large to come to consensus about whether the world is how it should be, or if it needs to be improved, and if so, how we should go about improving it. This once again limits what we can expect of purely technical approaches. My third and final point is that changing the reflection may or may not change the world. If the reflection itself is used to make important decisions, for example, whom to hire or what salary to offer to an individual being hired, then compensating for the distortions is worthwhile at that decision point. But the mirror metaphor only takes us so far. We have to work much harder, usually going far beyond technological solutions, to propagate these changes back into the world, not just brush up the reflection. So let me give an example of a concrete approach that focuses on representation equity in a technical setup. And I will use here one of my favorite gadgets, and that is set selection and ranking. Consider the task of selecting 4 candidates among 16 job applicants. Our goals here are twofold. The first is diversity. We wish to include 2 candidates of each gender and at least 1 of each race. The second is utility, maximizing the sum of scores of the selected candidates subject to diversity constraints. You can see the list of candidates in the table here along with their scores, and the higher score is better. For example, candidate A has score 99 and L has score 83. Observe that male candidates in my example have higher scores than do female candidates of the same race, and that whites have higher scores than blacks and than Asians. The highest scoring set of 4 candidates, sorry, this animation is wrong, the highest scoring set of 4 candidates that satisfy the diversity constraints is highlighted here in blue, and it has the score of 372. If we consider the selected set more closely, we observe a problem. And that is that we picked the best scoring white and male candidates, A and B, but we did not pick the best Black, Asian, or female candidates. Note that this example was deliberately constructed to highlight the following. If some population groups have systematically lower scores, then it costs less to skip their best scoring members in the name of diversity. This runs contrary to the nature of the diversity objective, which is to equalize access to opportunity. This also represents unfairness under a particular belief system. Suppose that scores represent effort, for example, how hard someone had to study to do well on a test. We may take a relative view of effort and assert that scores are more informative within a group than across groups. Further, we may assert that it is important to reward effort. Taken together, these beliefs correspond to a luck egalitarian conception of equality of opportunity, which I'm denoting here with the rainbow unicorn. But there is something that we can do. Consider the set of 4 candidates highlighted here. This set includes the best scoring white and male candidates still, but it also includes the best scoring Black, sorry, just a moment. So this set meets the diversity constraints, and its score is slightly lower than the score of the blue set, but it contains the top scoring candidates of both genders and the top white and Black candidates. And so it's much better in terms of rewarding effort across groups than the original set was. Having stated our beliefs and observed the trade-off between diversity, utility, and fairness, we can now design an intervention. For example, we may compute unfairness for a particular group. Oh, sorry, I'm really not doing great today in this presentation. But having observed this trade-off, what we can do is we can design a new fairness measure that will allow us to balance unfairness across groups and to then implement it as another objective. And we did this in a paper that I'm citing here and showed that these trade-offs can be negotiated between utility, fairness, and diversity with a low utility cost. So let me now switch gears and discuss access equity. Access equity is concerned with having access to information, and that is features, data, and models that are needed to evaluate and mitigate inequity. The point of view that I will take here is primarily of mitigating technical bias, and that is making sure that we're able to catch and correct the imperfections and distortions in the data as it travels through complex data science pipelines. For this, let us consider Anne. She's a data scientist in the human resources department at a large retailer, and was tasked with developing a model that predicts the level of compensation to offer to successful job applicants to make sure that they are successfully hired. Anne includes candidates' self-reported demographic data together with their employment histories as input. Following her company's best practices, she's going to split her data into training, validation, and test. And then she will implement data pre-processing, joining a bunch of tables and then interpolating missing values. After that, she will perform model selection and finally tuning and validation. Next, Anne will consider the accuracy of the trained model, and she will observe a disparity. And that is that accuracy is lower for female job applicants. This presents yet another kind of an unfairness issue. Considering the complexity of the data pre-processing pipeline, Anne probably has a long night of debugging ahead of her. Thankfully, Anne has a hunch. She goes back to data pre-processing and observes that the value of the attribute age is missing far more frequently for female applicants than for male applicants. She compares age distributions by gender and notices differences starting from the mid-30s. Anne revisits the data cleaning step and selects a state-of-the-art data imputation method to fill in age in applicant demographics. Let's extrapolate from Anne's experience and list some other sources of distortions that we are going to denote technical bias that may arise during data cleaning due specifically to incorrect modeling assumptions. Consider a form that gives job applicants a choice of a binary choice of gender and also allows us to leave gender unspecified. And suppose that about half of the applicants identify as men and half as women, but that women are more likely to omit gender. Then if mode imputation is used, and that is replacing a missing value with the most frequent value for that feature, and this is the default in many libraries like scikit-learn, then all predominantly female unspecified gender values will be set to male. More generally, multi-class classification for missing value imputation will typically only use the most frequent classes as target variables, leading to a distortion for a small population group, because membership in such a group will never be imputed. Next, suppose that some individuals identify as non-binary. Because the system only supports male, female, and unspecified as options, these individuals will leave gender unspecified when they fill out their job application form. And here, once again, if mode imputation is used, their gender will be set to male. A more sophisticated data imputation method will still use values from the active domain of the feature, setting the missing values of gender to either male or female. This simple example illustrates that technical bias distortions can arise from an incomplete or incorrect choice of data representation. Importantly, it's been documented that data quality issues often disproportionately impact members of historically disadvantaged groups, and we risk compounding distortions during data processing with pre-existing bias in the data for such groups. In a recent line of work done jointly with Stefan Grafberger and Sebastian Schelter, we developed ML-Inspect, a lightweight data distribution debugger for data pre-processing pipelines. The ML-Inspect library extracts logical query plans, modeled as directed acyclic graphs or DAGs, as shown on the right here, of pre-processing operators from machine learning pipelines that use popular libraries like Pandas and scikit-learn, and combine relational operations with estimator transformer pipelines. These plans are then used to automatically instrument the code and trace the impact of operators on properties like the distribution of sensitive groups in the data. In the remaining few minutes, I would like to address the final and perhaps most difficult dimension, and that is outcome equity. It is concerned with whether and how we can assess and mitigate inequities that are outside the system's direct control. My thinking about outcome equity centers around interpretability and public disclosure. I like to think about interpretability using the nutritional label metaphor. The data management community to which I belong has been studying systems and standards for metadata provenance and transparency for decades. The needs of data equity systems are once again bringing these favorite topics into the spotlight, but with a twist. To differentiate a nutritional label from more general forms of metadata, we articulate several properties. The label should be comprehensible. It's not a complete and therefore overwhelming history of every processing step applied to produce the result. The information on a nutritional label must be short, simple, and clear. It should be consultative, providing actionable information, not just descriptive metadata. Based on this information, consumers may cancel unused credit cards and improve their credit score. And job applicants may take a certification exam to improve their chances of being hired in the future. Labels should also enable comparisons between related products, implying a standard. And finally, they should be composable and computable, derived automatically as data and decisions are produced by the systems. In a recent Wall Street Journal article, I wrote about how this metaphor can be used to provide the necessary insight into the hiring process for job seekers. And here's what such a label may look like for the application part of the process. I call this the posting label. A similar label called the decision label would be generated to explain the hiring outcome. This thinking is timely, among other reasons, because it can help operationalize the requirements for public disclosure that are coming to the fore as part of legal and regulatory conversations. I'm showing here a law, a proposed bill that was just voted and will become law on December 10th of this year in New York City. The intention of this law is to regulate the use of automated hiring systems. The law would require auditing systems for bias, as well as providing broad disclosure to job seekers, notifying them that they were evaluated by a tool rather than a human, and also telling them about the job qualifications and characteristics that the tool is using. But of course, a nutritional label is only useful if the consumer understands the meaning of the term calorie. Similarly, nutritional labels for algorithmic decisions require an informed recipient of this information. For this reason, I've been passionate about educational activities under the outcome equity umbrella. I'm showcasing here a course that will be piloted in January of next year at the Queens Public Library in New York City. The course is called We Are AI. It's developed in collaboration with P2PU, a public education nonprofit, and all course materials are publicly available online at the link I'm showing here. Please take a look. Materials for the course include a series of videos and also comic book series, and both can be used independently. Everything is in the open source on GitHub or on YouTube. I'm showing the comics here. Again, please take a look, share, and let me know what you think. I also have been teaching current and future data scientists on these topics, mentioning here a course that I've been teaching at NYU called Responsible Data Science. Again, all materials are public. Please let me know what you think if you decide to use them in your teaching activities. And finally, another comic book series for the more technically inclined. The first volume, called Mirror, Mirror, has been translated into a couple of languages, and we're looking to come up with more translations. It's now time to wrap up, and I would like to leave you with a few parting thoughts. In my talk, I gave a perspective on data equity systems, albeit very briefly. I grounded the discussion in automated hiring tools, a specific use case that gave us ample opportunity to both appreciate the potential benefits of AI in an important domain and also to get a sense of the ethical and legal risks. It's clear to me that we technologists have an important role to play. But to do so, we must step outside our engineering comfort zone and start reasoning in terms of values and beliefs, in addition to checking results against known ground truths and optimizing for efficiency objectives. This seems high risk, but one of the upsides is being able to explain to our children what we do and why it matters. And another point that I would like to make is that we cannot fully automate responsibility. While some of the duties of carrying out the task of, say, legal compliance can in principle be assigned to an algorithmic system, the accountability for the decision being made always rests with a person. This person may be a decision maker or a regulator, a business leader or a software developer, or importantly, a member of the public. For this reason, I see the role of us technologists in helping build systems that expose the knobs of responsibility to people. And of course, the systems we're building are not simply technical, they are socio-legal technical, and technology is in some sense the easy part. And this means that to expose the knobs of responsibility, we must work together to create meaningful regulatory mechanisms, a topic that I'm very interested in, and I only had time to mention it briefly today. I also see as part of our responsibility as technologists and educators to help create a new generation of AI practitioners and an informed public. Thank you very much for your attention. The graphics that I used in my talk today are due to the very talented Fala Arif Khan. Thank you.
Thank you so much, Julia, for this brilliant talk.
Sorry,
Now,
I tripped up there in the middle a little bit.
oh, that was perfect. It was very, very good. Thank you so much. Okay, now we move on to Professor Thomas Douglas' talk. Professor Douglas is Professor of Applied Philosophy at the Oxford Uehiro Center for Practical Ethics, where he's the Director of Research and Development. He's also a Senior Research Fellow at Jesus College in Oxford, and editor of the Journal of Practical Ethics and principal investigator on the project Protecting Minds, the Right to Mental Integrity in the Ethics of Irrational Influence. Tom, welcome, and you have the floor.
Thanks very much, Nita, and thanks for the invitation. Can you all see my slides?
Yes.
Great. Thanks. So, yes, I'm afraid this is going to be, this talk's going to be a significant change in direction from the previous three very interesting talks in AI ethics and data ethics. So this talk is a talk in neuroethics. It is a topic that I think has some interesting connections to some questions in AI ethics as well, some of which I've done a little bit of work on. I'm for the most part not going to actually mention those connections in the talk itself, but would be happy to come back to them in the Q&A. And it's also, I'm afraid, going to be much less technically and scientifically sophisticated than the previous three talks. I'm going to focus almost entirely on the sort of normative questions. Okay, so I want to begin with a case, a hypothetical case. Suppose that Mr. J is a repeat violent offender who's been imprisoned several times. He now comes before the courts for sentencing following his most recent assault conviction. And let's suppose that the normal sentence at this point would be a further 3-year period of imprisonment. But medical experts attest that a new aggression-lowering drug could be given to Mr. J, and that this would be more effective at preventing him from reoffending in the long run than sending him to prison for 3 years. And let's suppose also that this drug would be safe, by which I mean simply that it would have a sort of side effect profile similar to some of the most widely used brain active drugs, like think of, for example, the most widely used antidepressants. So one question we might ask about this case is, could the government justifiably require Mr. J to take this drug as part of his criminal sentence? And that's more or less the question that I'm going to address in this talk, except at a more general level. So the question will be, could the state be justified in requiring some individuals convicted of serious crimes to undergo neurointerventions as part of their criminal rehabilitation? And by neurointervention, I just mean any intervention that intentionally modifies brain activity through direct chemical or physical means, as opposed to psychological means. The brain active drug that I mentioned in my hypothetical example, aggression-lowering drug, would be an example of a neurointervention. That was a science fiction example. We don't currently have safe and reliable aggression-lowering drugs of the sort that are already being used in criminal rehabilitation. But actually, we don't have to go to science fiction examples to illustrate neurointerventions being used in criminal rehabilitation. So several jurisdictions do already use, for example, SSRI antidepressants or testosterone-lowering agents to try to suppress sex drive in sex offenders. This would count as a neurointervention, in my view. You might think it's a little bit strange to refer to suppressing someone's testosterone levels, so-called chemical castration, as a neurointervention, given that it sort of most immediately acts on the hormonal system rather than on the brain. But of course, it produces its effects on sex drive via affecting the brain. Another example that we might think of is the use of method and maintenance therapy in order to suppress addictive desires. This is also used in several jurisdictions in the context of criminal rehabilitation in individuals who have been convicted of drug-related offences, typically in people with heroin addictions. So there are already examples of neurointerventions being used in criminal justice systems, at least in many jurisdictions. So just to sort of highlight how widespread this is, chemical castration is used in about 8 or 9 US states and also in several continental European countries. I'd be interested to hear what the situation is in Brazil. Still, I think that actually the main reason to be interested in my question is because of the possibilities for future neurointerventions that might be used. So we might well imagine that in the future we will have anti-aggression drugs like the one that I mentioned in my hypothetical example, or perhaps drugs that could help to improve impulse control. And it's not difficult to imagine that these might be used or at least advocated for use in criminal rehabilitation. And then there are also non-pharmacological kinds of neurointerventions that might be used. And this is actually one of the places where there's a connection with AI ethics, because one of the types of neurotechnologies that some have suggested might end up being useful in criminal justice contexts, so-called closed loop devices. So these are effectively devices implanted in your brain that can read your brain activity and then can also influence your brain activity in response to what activity they have read, and they would usually be programmed with some kind of algorithm, perhaps based on machine learning, in order to respond to detected brain activity in order to influence it in some desired way. So again, you can imagine that might be used to, for example, control impulses in people who are prone to impulsive violence, and again, might be advocated for use in criminal rehabilitation. Okay, so those are the kinds of interventions that I have in mind in this talk. How exactly might they be used in a criminal justice context? Well, if we take the examples of chemical castration and methadone maintenance therapy as a guide, there are 2 main ways in which we might expect them to be used. So the first possibility is that they might be imposed as part of a criminal sentence, perhaps in addition to a more traditional criminal justice intervention like imprisonment. So a person might be sentenced to a period of time in prison, followed, for example, by a period of time receiving some neurointervention. And this is the approach that's taken to chemical castration, actually, in most of the American states that use it. The other possibility is that they would be imposed not as an absolutely mandatory part of a criminal sentence, but as an alternative to some other criminal justice intervention. So typically what the situation would be here is that an offender might be sentenced to a period of time in prison, then they might be offered parole or early release, but on the condition that they agree to undergo some neurointervention, or probably more likely some treatment program of which a neurointervention would be one element. So then the offender would effectively face the choice between staying in prison, perhaps until the end of their initial sentence, or being released, but then undergoing the neurointervention for some period of time, or perhaps until some treatment outcome has been achieved. And this is the approach that's taken to chemical castration in most of the European countries that use it. Now, you might think that these 2 approaches would raise rather different ethical issues, and in particular that the second approach would be less problematic than the first, since it gives the offender some choice as to whether they undergo the neurointervention. Interestingly, though, actually most critics of the use of neurointerventions in criminal rehabilitation have kind of objected to both of these practices simultaneously, and that's because they've thought that even when offenders have the option of remaining in prison and avoiding undergoing a neurointervention, they don't have a real choice because their choice is coerced. So let me give a couple of examples of people making this claim. So here's a forceful but fairly typical statement of the view from an American legal scholar, Carrie Vanderzyl. The doctrine of informed consent requires a knowledgeable and voluntary decision to undergo treatment, yet offering a convicted offender castration, chemical castration, which I was thinking of, as an alternative to a lengthy prison sentence, constitutes an inherently coercive practice, rendering truly voluntary consent impossible. Another statement from another American legal scholar, William Green. The offender is faced with two options: a lengthy prison sentence on the one hand, and Depo-Provera, which is the trade name for one of the drugs used in chemical castration in the US, Depo-Provera on the other, and cannot be said to have the capacity to act freely in making a choice. Freedom of choice is impossible because the convict's loss of liberty constitutes a deprivation of such a magnitude that he cannot choose freely and voluntarily, but he is forced to give consent to an alternative he would not otherwise have chosen. Okay, so I think that in these claims, which sort of reflect, I would say, the dominant view of at least sort of bioethicists and legal scholars on the use of neurointerventions in criminal rehabilitation, there are, I think, really two claims being made here. One claim is that offering the choice between further imprisonment and undergoing a neurointervention is a coercive situation, and that this coercion invalidates the offender's consent, so that even when even though there's a sense in which the offender agrees to undergo the neurointervention, in these cases, that consent is invalid. It doesn't have its normal normative force in making something that would otherwise be wrong permissible. And then the second claim, which is kind of implicit but clearly at work here, is that valid consent is required in these cases. In other words, it would be unjustified to use these neurointerventions in criminal offenders without their valid consent, or non-consensually, as I will say. So what I want to do in the rest of the talk is to respond to both of those claims. I want to put some pressure on both of those claims. So I have two responses. First response is, in response to the first claim, is to argue that offering the choice between further imprisonment and a neurointervention needn't always be coercive, and so needn't invalidate consent. And then my second response, which is a response to the second claim, will be to hold that even non-consensual neurointerventions in criminal justice could potentially be justified in some cases. Okay, so let me do the first response first. I'm going to have to do this very briefly, but happy to go into more detail in the Q&A. So the charge of coercion being made in the two quotes that I gave earlier seem to be based on the idea that if you're an offender in prison offered early release on the condition of undergoing a neurointervention, you will face an extremely strong pressure to opt for the neurointervention over incarceration. And that seems to be the thinking behind the idea that there's coercion in these cases. And it's true that sort of classic or paradigmatic cases of coercion do involve a very strong psychological pressure. So think of the classic sort of highwayman case where someone stops you and holds a gun to your head and says your money or your life. You have to either hand over your money or the person is going to shoot you, at least if the threat is a credible one. That's a case, obviously, where you will feel strong pressure to hand over your money. And it seems to be part of why we think that in handing over your money, you're not actually validly consenting to the person taking your money. But clearly, strong pressure isn't enough for coercion. The case that most philosophers who work on consent use to illustrate this point is known as the terminal cancer patient case. So imagine you've got very advanced cancer, which will almost certainly be terminal, and then a doctor offers you a treatment which holds out some prospect of curing your cancer and giving you many years of further life. Clearly, you will face very strong pressure to agree to undergo that treatment. The outcome, if you don't agree to it, is a very bad one indeed. But we wouldn't say in this case that the doctor is coercing you. So strong pressure is not enough for coercion. What is the extra factor that's required in addition to strong pressure in order for there to be coercion? And in particular of interest to me here is coercion of a kind that would invalidate your consent. Well, there's lots of disagreement about this. I can't go into all the different theories of coercion, but let me just mention a couple of examples. So one view that some people have is that in order for strong pressure to be coercive, the person exerting that pressure has to be exerting it for the purpose of controlling the coercee's behavior. Another view is that for strong pressure to be coercive, there has to be pressure that's exerted by threatening to wrong someone or to infringe someone's rights, and that's what makes the strong pressure coercive, the threatened rights infringement or threatened wrong to the coercee. And notice that if you have either of these views, then it's not at all clear that offering someone a neurointervention as an alternative to further incarceration would be coercive. It may not be that the state in making this offer is trying to control or even influence the offender's behavior in any way. They may just simply think we've got these two different ways in which we can kind of keep the public safe from you as a criminal offender and potential reoffender. One is for you to stay in prison, the other is for you to undergo the neurointervention. We want to give you as much choice as possible about which of those interventions you undergo. There's not necessarily any intention to influence the offender one way or the other. And similarly, it's not clear that there's any threat to wrong the coercee in these, or the putative coercee in these cases. The state, presumably if the person refuses the neurointervention and is kept in prison, if we think that imprisonment would be permissible, because we think that the general criminal justice system is ethically justified in the first place, then there wouldn't be any threat to wrong the coercee in these cases. Now, that would be different in the context of a jurisdiction where we think that the criminal justice system is actually systematically wronging offenders by locking them up in prison. But at least in principle, it's possible that the threat to keep someone in prison if they don't agree to a neurointervention would be permissible and would not wrong the offender. So it doesn't seem like there'd have to be coercion in these kinds of cases. And just to make the sort of same point using an intuition bump rather than by referring to views about coercion, here's a case which I hope will get you more intuitively on board with the views that I'm pushing here, a case which I think is similar in structure to the case of offering someone a neurointervention as a condition of early release from prison, but which I think it's clear that we would say that there's no coercion. So suppose that there are two types of prisons. There are hands-off prisons and hands-on prisons. In the hands-off prisons, offenders are kind of more or less left to their own devices. They're not offered any kind of rehabilitative interventions like psychological therapies or anger management courses. They're just kind of left on their own. The hands-on prisons are much more proactive, and they offer offenders all kinds of psychological rehabilitation programs to try to reduce the risk that they will reoffend after release. And let's suppose that a short period in a hands-on prison is about effective in preventing recidivism in the long run as a longer period in a hands-off prison, and they cost about the same amount of money to the state. Most offenders strongly prefer a shorter period in a hands-on prison, but some do not. And the government wants to give offenders as much choice as possible, so it allows them to choose between the two different types of prison. Now, in the context of this choice, many offenders will presumably feel a strong pressure to opt for the shorter period in a hands-on prison because they regard it as very bad to be in prison for a longer period of time. But I don't think we would think that offering this choice is coercive, and I want to suggest that this choice is analogous, with respect to coercion at least, to the case of offering a choice between a neurointervention and remaining in prison. Okay, so that's all I'm going to say by way of my first response to the concern about coercion. For the rest of the time I have, I want to advance my second response, which is to argue that even non-consensual neurointerventions in the context of criminal rehabilitation could be justified. And I'm going to first sort of state the case in favor of the acceptability of non-consensual neuro interventions in criminal justice. I'll do that quite quickly because I think the case in favor is fairly straightforward and in a way not that interesting. And then I'll spend more time on considering the case against, so the kind of potential objections to my view here. So the case in favor of the view that non-consensual neurointerventions could be permissible in criminal justice begins with the observation that we often think it's morally permissible to treat criminal offenders in intrusive and somewhat harmful ways without their consent. We don't typically seek consent from offenders before locking them up in prison or fining them or requiring them to complete community service or even in many cases participating in psychological rehabilitation programs. Why do we think that this is permissible? Well, one thing is because we think that the interests of third parties at stake, and we think that it can be justified to harm one individual in order to protect innocent third parties from greater harm. That seems to be part of what's going on in justifying our criminal justice system's responses to offending. And then the other part of the story that I think is also playing an important role on most people's thinking about criminal justice is that we think that in committing a serious crime, you make yourself morally liable to certain kinds of intrusive and somewhat harmful interventions. So you partially waive or forfeit your rights against certain kinds of intrusive or harmful treatment. And that's why we typically think that it can be permissible to imprison serious criminal offenders, even though we wouldn't think it would be permissible to imprison people who I think are just as likely, just as dangerous in the sense that they're just as likely to commit crimes in the future, but haven't ever committed a crime in the past. We seem to think that past offending makes a difference to what kinds of steps we can take to protect the public from further criminal offending by an individual. And that suggests that we think that in committing an offense, a person has made themselves morally liable to certain forms of intrusion that would otherwise be unjustified. So for those reasons, we think that most of us at least think that certain kinds of intrusive and harmful interventions in the context of criminal justice can be justified. We might think that most of what actual jurisdictions are currently doing is not justified, as perhaps, I would say that the dominant view amongst legal philosophers is that almost all criminal justice systems in the world are far too harsh and are actually wronging offenders by locking them up for far too long under very harsh conditions. But I think most people probably also think that in principle, certain kinds of intrusive and harmful treatment in the context of criminal justice could be justified. So that's the beginning of the case in favor. And then that sort of hopefully gets on the table the idea that neuro interventions could be justified even if non-consensual, because we don't typically require consent for other kinds of intrusive and somewhat harmful interventions in the context of criminal justice. And then the second part of the case in favor is to note that actually non-consensual neuro interventions would sometimes be ethically preferable to other non-consensual interventions that we accept, at least in part for the purposes of preventing reoffending in the context of criminal justice. And I'm thinking here of mainly two kinds of non-consensual interventions that we currently accept. One is imprisonment, and the other is psychological rehabilitation programs like anger management courses or impulse control courses. So why I think that non-consensual neuro interventions might be preferable to these? I'm going to illustrate this using the comparison with imprisonment, but I think actually similar comments could be made in comparison to psychological rehabilitation programs. My thought is that non-consensual neuro interventions could be more effective, safer, and cheaper than traditional criminal justice interventions, and that would make them ethically preferable. So consider first effectiveness. Imprisonment is famously not very effective at preventing reoffending. Actually, in many classes of offenders, it has a criminogenic effect in the sense that offenders seem to be more likely to reoffend following release from prison than they would have been had they never been imprisoned, for certain types of offences at least. You might think that at least during the period of imprisonment is quite effective at preventing reoffending, but actually, given that rates of offending within prisons are typically very high as well, it's not so clear that there's a very large preventive effect there either. So it would not be very difficult for a neurointervention to be more effective than imprisonment at preventing recidivism over the long run. And actually, I would think that, for example, chemical castration probably already has a better evidence base supporting its effectiveness at preventing recidivism than imprisonment. It doesn't have a particularly strong evidence base. There's not very high quality evidence studies of chemical castration. The evidence that we do have, though, does show quite a significant preventive effect in preventing recidivism in certain classes of sex offenders. And that's more than we can say for imprisonment in most cases. Similarly, safety, imprisonment is a very unsafe intervention. If it was a medical intervention, it would never be approved for use. It has a lot of negative side effects, disruptive of people's careers and relationships, tends to be associated with high risk of mental health conditions and sometimes physical health conditions as well. It would not at all, again, be difficult for neurointerventions to be safer than imprisonment in the sense of having a better side effect profile. And again, I would say that chemical castration, for example, already fits into this category of being safer than imprisonment. And that's despite the fact that by the standards of medicine, chemical castration actually is not an especially safe intervention. It does have quite a few side effects. And then finally, cost. Imprisonment is extremely costly. It's about hard to kind of get accurate figures on exactly how, I mean, it depends on the nature of the technology on exactly how much cheaper a neurointervention might be. But if you think that the cost of a neurointervention would be similar to the cost of a standard psychiatric treatment, plus the kind of costs of monitoring an offender post-release from prison, a kind of probation regimen, those costs combined would probably be at most about 10% of the cost of imprisonment. So it would be at least 10 times cheaper than imprisonment for a relatively cheap neurointervention. So for those reasons, you might think there'd be a reason to prefer non-consensual neurointerventions to imprisonment, even I think to more enlightened forms of imprisonment that are the most likely to be justified, the kinds of forms that are employed in Scandinavian countries, for example. You might think that neurointerventions would be ethically preferable. Okay, so that's the end of the case in favor. Let me now move on to the arguments against non-consensual neurointerventions, which, as I said, I think are kind of where most of the interesting questions lie. So I'm going to, if I have time, consider five arguments against non-consensual neurointerventions and criminal rehabilitation. I'll try and do the first three very quickly so I can spend more time on the last two, which I think are the most persuasive and plausible. So the first worry that most people raise when I talk about this topic is that non-consensual neurointerventions might be highly prone to misuse. So even if we can imagine sort of isolated circumstances in which it would seem permitted to use, ethically permissible or acceptable to use these interventions, we wouldn't be able to trust the courts to impose them only when their use is justified. And typically this concern is kind of connected with observations regarding the history in the 20th century of neurotechnological or medical solutions to criminality. Things like the use of electrical brain implants and frontal lobotomies and other kinds of so-called psychosurgery to try to make criminal offenders less aggressive or less inclined to commit crimes. And there are lots of examples of these technologies being used in the middle parts of the 20th century, sort of without any regard for safety or effectiveness, and often in quite horrific ways, often also in individuals who had been convicted of crimes, which we would now generally think shouldn't have been crimes at all. So pictured on the right there is Alan Turing, the British computer scientist who was famously convicted of homosexuality and was offered chemical castration, actually in return, in a similar way to what I've been talking about, as in return as an alternative to imprisonment. He agreed to the chemical castration, and then as a result, it's thought of side effects of that intervention, he committed suicide. So we have lots of examples of the misuse of medical neurotechnological solutions to crime in the 20th century. And one lesson that some people think we should draw from that is just that humanity is kind of chronically over-enthusiastic about these potential solutions to crime. We couldn't trust ourselves to use these interventions judiciously. Instead, we should be worried that courts would become over-enthusiastic about using these interventions and would use them even in cases where they're not justified. Now, in some ways, it's sort of difficult to respond to this worry as a philosopher, because it's based on a lot of empirical assumptions about how our courts will behave in the future, which a criminologist or sociologist would be better placed to answer. But I do think there are some reasons to be a little bit skeptical of this objection. I mean, the first thing to note is that there has been a kind of major, at least in many sort of enlightened democracies, there's been a fairly major ethics revolution in medicine and psychiatry and neuroscience since the middle parts of the 20th century. I mean, there were all kinds of examples of kind of what we would now think of as horrible abuse of patients in medicine, in all kinds of areas of medicine in the middle parts of the 20th century, people being enrolled in quite risky trials without their consent, people being experimented on during surgical procedures without their knowledge, people being routinely not informed of their diagnoses. There are all kinds of ways in which medicine, and including psychiatry, has become more enlightened since the middle parts of the 20th century. So that might lead us to think that the risk of misuse would at least be lower now than it was at that time. And in fact, I think you could argue, and I would want to argue, I think that there's actually a greater risk of misuse with more traditional kinds of criminal justice interventions now than there would be with neurointerventions, because there hasn't really been the equivalent of the medical ethics revolution in criminal justice ethics. And we haven't become all that much more enlightened with our criminal justice practices since the middle parts of the 20th century. And in fact, I would say the dominant view of penal theorists and legal scholars of criminal justice would be that almost all countries are actually currently systematically misusing incarceration, in the sense that they're incarcerating people for too long in too harsh conditions. So I think you might argue that neurointerventions would be less likely to be misused than traditional remedies at this point. The second objection that might be raised to non-consensual neurointerventions in criminal justice is what I call the argument from professional ethics. So presumably we would want healthcare professionals to be involved in the administration of these interventions in order to ensure that they would actually be safe and effective in a particular individual. But the worry is, in doing so, we would be requiring these healthcare professionals to act against their own kind of professional ethical requirements. Many people think the healthcare professionals should act only in the interests of their own patients, not in the interests of third parties. Many people also think that healthcare professionals should not act as kind of agents of the state, but should act from their own kinds of values, or their own professional values at least. So the worry would be that psychiatrists or any other kinds of medical professionals that might be involved in administering neurointerventions would be infringing their professional ethical obligations. I think, though, that this objection relies on a fairly kind of quaint, outdated conception of what the professional obligations on medical professionals really are. There are all kinds of areas in which we already expect medical professionals to act not solely in the interests of their own particular patients who are in front of them, but to protect third parties. Think of the role of doctors in implementing quarantine and isolation and vaccination, for example. These are all interventions intended partly, or in some cases solely, to protect third parties. And we also often, in doing so, are effectively expecting healthcare professionals to act as effectively agents of the state, implementing, for example, public health measures. Similarly, rationing or resource allocation decisions is another area where we expect doctors, at least in many public healthcare systems, to act in the interests of third parties, not their own patients, by, for example, not offering extremely expensive and not very cost-effective treatments, even if those treatments would be actually beneficial to the patient. So I think that this is not the case, that we think that doctors should only act in the interests of their own patients. Third objection that might be raised to non-consensual neurointerventions, and this has actually been raised by courts in the US in relation to the use of chemical castration there. And this is the worry that these neurointerventions might actually be not harmful enough to meet the goals of criminal justice. So I've been assuming throughout this talk that part of the point of criminal justice systems is to prevent convicted offenders from reoffending. But of course, you might think that criminal justice systems also have other purposes. Some people think that our criminal justice system should be retributive, so they should inflict deserved suffering on offenders that's kind of proportionate to the moral wrongness or moral blameworthiness of the crime that's been committed. Some people think that criminal justice systems should play a deterrent role, so they should be discouraging other people from offending. And if you think that our criminal justice system should be retributive and or deterrent, then you'll want them to be inflicting some kind of harm on offenders, because otherwise they won't achieve these goals. And some people think that imposing neurointerventions, which are actually for many offenders likely to be beneficial rather than harmful, would not achieve this purpose. I think there are lots of responses that could be offered to this, this objection. But let me just mention one, which is that we could simply avoid this objection just by supplementing neurointerventions with other kinds of more traditional criminal justice interventions that are intended to achieve the deterrent and retributive goals of criminal justice, if we think that the criminal justice system should indeed be retributive and deterrent. So you could use fines or probation regimens, for example, to try to achieve the deterrent and retributive objectives of criminal justice. And in fact, I think you might think that there would be some advantages of kind of separating out the different purposes of criminal justice and trying to pursue those different purposes using different interventions rather than just using a single blunt intervention like imprisonment to try to realize all of these objectives in one go. Separating the interventions out might allow us to kind of more finely tailor the criminal justice system's response to a particular crime than using a very blunt single intervention. Okay, so let me move now on to two objections to non-consensual neurointerventions, which I think have a bit more going for them than the three that I've already discussed. So the first of these holds that non-consensual neurointerventions would involve an objectionable form of bodily interference and would thereby violate the offender's right to bodily integrity. So in medical ethics, it's standardly thought that patients enjoy a right to bodily integrity, which I'm understanding here is simply a right against certain forms of interference with your body. And it's because we possess this right that most people think that you need to have consent from a patient before implementing any kind of physically invasive treatment on them, like a surgical procedure or injecting them with a drug or a vaccine, for example. And non-consensual neurointerventions would, of course, infringe this right because they would involve interfering with a person's body without their consent. And I've got a picture of John Locke on this slide, just to remind me to say that, you know, this idea of a right to bodily integrity or a right against bodily interference has a strong philosophical pedigree, is often traced to the idea that we have kind of property rights over our bodies as part of our rights of self-ownership, which is an idea that's often traced to John Locke, but has, of course, many other influential defenders as well. Okay, so what should we make of this? And actually, something else I should say about this objection is that it has the advantage also of potentially explaining why we might think that non-consensual neurointerventions are problematic, even if we think that imprisonment is not. Because you might think that imprisonment doesn't involve, it involves externally constraining a person's body, but it doesn't involve actually intruding on a person's body, and therefore arguably doesn't infringe the right to bodily integrity in a way that a non-consensual neurointervention would. It also kind of allows us to deal with the concern mentioned in the previous objection that, well, it allows us to explain why non-consensual neurointerventions might seem to be problematic, even if they're beneficial, even if they actually benefit the offender more than they harm the offender. So we tend to think in medicine that even beneficial treatments can't be imposed on patients without their consent, because doing so would infringe their right to bodily integrity. So the right to bodily integrity isn't a right against harm, it's a right against interference with your body, even if that interference would benefit you. So what should we make of this objection? Well, I think, again, there are several responses that could be made. I'm just going to mention two of them here, but happy to talk further in the Q&A. I mean, the first point to make is that most of us don't think that the right to bodily integrity or the right against bodily interference is absolute. We think there are circumstances in which it can be justifiably infringed. The most obvious example, particularly in present circumstances, is pandemic control. Many people think that compulsory treatment or compulsory vaccination can be justified in the context of a pandemic. Those are somewhat controversial, but much more widely accepted is the idea that at least compulsory testing for an infectious disease can be justified in the context of a pandemic, even if it involves having a swab stuck up your nose or into the back of your throat. That's a somewhat physically invasive intervention that interferes with your bodily integrity, but most people think it can be justified if there's a significant enough benefit to third parties. And that's even in a context where there's no issue of moral liability. So we don't typically think that people with COVID are morally liable for any kinds of intrusive treatment that other people are not liable to, but we just think that the potential risk to third parties is sufficient to justify infringing their right to bodily integrity in certain ways. The other point to make here is that neurointerventions could in fact involve extremely minor forms of bodily interference that arguably don't implicate the right to bodily integrity at all. So think of something like transcranial direct current stimulation, which involves stimulating the brain using electrodes placed on the scalp. This seems to involve a very minor kind of physical interference. And in fact, from a legal point of view, it would typically be regarded as a non-invasive intervention. You might question whether it should be regarded in that way, but certainly it doesn't seem to involve a very serious physical interference with the body. So you might think that it would not be, if it does implicate the right to bodily integrity at all, it wouldn't implicate it in a very severe way. I'm assuming here, and I'm happy to defend this in the discussion, that the right to bodily integrity sort of provides stronger protection against more invasive forms of intervention and weaker protection against less invasive forms of intervention. Okay, I need to finish quickly, so let me just finally say something about the fifth objection, which I think is the most persuasive objection to non-consensual neurointerventions. This is analogous to the appeal to bodily integrity, but it appeals to what I'm calling a right to mental integrity. So you might think that non-consensual neurointerventions would involve an objectionable form of mental interference, with our minds or mental lives, and that would thereby violate the offender's right to mental integrity. Understood again simply as a right against certain forms of mental interference. Now, interestingly, there isn't really a very established right to mental integrity. It's much less discussed and certainly in the law, much less firmly established than the right to bodily integrity. But some legal scholars, pictured here on the slide, have recently argued that we should recognize a right to mental integrity, or right against interference with our minds. I think you can quite easily appeal to intuitions about cases to support this idea that we should recognize such a right. Most of us would think that something like non-consensual hypnosis or aversion therapy, I'm thinking of the kind of interventions used in A Clockwork Orange, for any of you who have seen the film, we would think that these interventions seriously infringe someone's rights, even if they don't involve any significant form of physical or bodily interference. And I think that the best way to explain why they are problematic and why they typically shouldn't be performed without consent, would appeal to the idea that we have something like a right to mental integrity, a right against interference with our minds. There are also, I think, theoretical sort of philosophical arguments that could be given in favor of recognizing a right to mental integrity, a right against mental interference. In particular, we could simply invoke the same kinds of considerations that tend to get invoked in support of the idea that we possess rights to bodily integrity. For example, we could appeal to the idea of self-ownership. If we have property rights over ourselves, and if those give rise to rights over our bodies because of the close relationship between the self and the body, then presumably they should also give rise to rights over the mind, given that the self and the mind are, if anything, even more closely related than the self and the body, at least on most philosophical accounts of the self. some proponents of self-ownership seem to, in fact, explicitly recognize this. John Stuart Mill basically describes or defines self-ownership as ownership over the body and the mind. So you might think that that should give rise to rights against mental interference that mirror the rights against bodily interference that we tend to accept as aspects of our self-ownership. So I think that there's, again, I think that it is plausible that we possess a right to mental integrity, and that this would be infringed by non-consensual neurointerventions. But one issue here is that we need to distinguish, we're going to now have to come up with some kind of account of what kinds of mental interference or mental influence, if we want to be more neutral about describing it, actually infringe this right. Because there seem to be all kinds of ways in which we influence one another's minds by giving them philosophical arguments, for example, that don't seem to infringe a person's rights, even if they're done without that person's consent. If I sort of stop someone on the street and start giving them philosophical arguments, we won't think that I've infringed any right that they might possess over their minds, even though I might succeed in changing their mental states in some way, and even though I've done it without their consent. So we need some story now about what kinds of mental influence or mental interference might infringe this supposed right. And this is actually what my current research is mostly focusing on. I'm not going to go into that here, but I'm just going to end with a case which I want to use to suggest that it's going to be very difficult to kind of draw a distinction between acceptable and unacceptable kinds of mental interference in a way that would suggest that non-consensual neurointerventions would always infringe the right to mental integrity. So here's the case, and I'll just give the case and then basically stop at that point. So suppose that the superintendent of a prison is concerned about a recent spate of attacks by prisoners on prison guards. She reads that another prison was able to reduce prison violence by having the prison's walls painted in a soothing shade of green. Seeing the walls tends via subconscious mechanisms to have a calming effect that made inmates, prisoners, more resilient to provocation, so less likely to respond violently when provoked, for example, by other prisoners or by guards. So suppose that the superintendent decides to adopt the same strategy in her prison. The walls of the prison are repainted in this soothing shade of green, and rates of prison violence do indeed fall. So I just want to make two suggestions about this case. The first is that intuitively it seems ethically acceptable or permissible. Maybe there's something ethically problematic about it. I'm sympathetic to that thought, but we probably still think that if it's significantly effective in reducing violence within prisons, then it would be justified to employ an intervention like this. So maybe we should say that it infringes the right to mental integrity, but does so justifiably. And then the second suggestion I want to make is that the kind of mental influence or interference involved in this kind of case is not clearly any more problematic than the kind that might be involved in an analogous neurointervention. Suppose we had some drug that we could spray into the prison's air that, when inhaled, had a similar effect on levels of aggression in offenders. I think it's very hard to tell a story about why that non-consensual neurointervention would be more problematic with respect to mental integrity or mental interference than this wall painting intervention that I've given. And that I think makes it difficult to sustain the view that the non-consensual neurointervention would be ethically unacceptable. Okay, I had a few other slides, but I think I'll stop there since I've gone over my time already. Thank you.
Well, thank you so much, Professor Douglas, for this beautiful talk. Now we have some minutes left for the Q&A session, and I'll just write down the 4 questions I gathered from the chat so that everyone could see. I'll just read them, and each one of you could address these questions. First of all, there was a question for Professor Julie Stoyanovich. Could you say something about your research on data equity applied to the ongoing times of global COVID pandemics? There was also a question from Professor Kluge to Nicholas. Could you please tell a few words about surveillance capitalism and digital ethics? Thank you. Also another question for Professor Bueno. Given your work in empiricism and methods of inference in mathematics and science, what do you make of the problem of data interpretation? And finally, there is another question for Professor Thomas Douglas. How do you relate justifiable non-consensual neurointervention, assuming it is more effective, safer, and cheaper, to moral enhancement as advocated by your colleagues, Ingmar Persson and Julian Savulescu? So if we could keep this order, perhaps Julia, you can go first.
Sure, thank you. So I just pasted the link into chat here that is visible to everyone to a paper that I co-authored specifically on this question, actually, about how COVID-19 makes the data equity challenges more urgent. And the reason for this is that when we are in a regime in which we have to make decisions very quickly based on data that we get opportunistically and where impacts are, really broadly felt, like where should we be putting more or fewer testing sites, what should be our policy with respect to contact tracing, where should there be more emergency room beds allocated, right? Then it really is crucial for us to be thinking about how representative the data is that we're collecting. And what we have been seeing, I think, throughout the world is that the COVID pandemic is bringing out this mistrust, particularly that the marginalized communities have of any government interventions, and specifically of data collection on the part of a government or vaccination efforts, right, lately. So taking this as a given, understanding that the data that we have is not representative of the population overall, and understanding that data is missing, not at random, right? It's missing for reasons that are socially grounded, should inform what we do with the data. So for example, we can use methods like synthetic or semi-synthetic data generation to augment the data that we have about, let's say, positivity rates, to fast forward the world to a place where it would be more acceptable and more equitable, and then build our predictive models on such augmented data sets, but doing this judiciously, not kind of silently. So this would be the quick answer. And an even quicker answer maybe is just please take a look at the paper, and I'd be more than happy to be in touch also offline about this.
Thank you very much. Nicholas?
Yes, so answering the question of the professor, for some people who don't know the term surveillance capitalism, is the idea of commodification of personal data. And like, actually also like the idea of like, basically one of the premises of capitalism is like that anything can be commodified. Practically everything can be commodified, can be turned into a commodity. So for example, like I don't use Facebook, but many people use Facebook, and like people say, Facebook is free, and actually Facebook is not free. They are commodifying your attention and your preferences and your information. And there are so like surveillance capitalism talks about that we live in a time then like our ideas and our preferences and our opinions and even our beliefs are being hijacked and commodified. For example, nowadays advertising companies can like map your preferences and give advertising certain types of advertising that are optimized for your preferences. And like this is the commodification of your attention. Your attention like is worth money, and like shaping your beliefs is worth money. So like this can be like this can be interesting for example, like it's interesting to have like self-optimized technology. For example, I like that, well, like when I open my YouTube tab, like it has videos that like I find like I like those things. But the problem is also like much of these the thing that is being optimized is not just my values, but like what is actually, I think the main force is being optimized in a surveillance capitalist society is the profit making. Like the things that are being commodified and like the things that are being self-optimized are the things that make in some way or another profit. So like a driving force for this self-optimization society is making money, making more profit, making more capital. And like this is go back to my research, because it's a question of alignment with what are we aligning, sorry, English is not my first word. With what are we aligning the use of our technology? Are we aligning with the preferences of the majority? Are we aligning with the preferences of the marginalized? Are we aligning the self-optimization profit with the blind production of capital? What are we doing? So I think it's really interesting. Like I'm not a really like I have some colleagues here who study a lot of critical theory, and like they would be much more able to answer this than for me. But like to me, this is what I think. This is my very 5-minute introduction to surveillance capitalism, and I think is in the end is kind of linked to the question of alignment. Like, what are we aligning the objectives that are being optimized by these systems? Is with our preferences? Is the preferences of everyone? Is the preferences, or is the preferences of the industry, of the capitalist society, or the production of capital? I think the answer is clear, and I don't need to give it. I don't need to spell out. Everyone knows, but it is. So, but thanks for the question.
Thank you, Nicholas. Professor Otavio Bueno, please.
Thanks a lot, Nita. The question is about how to interpret the data. And of course, this is a crucial question, because you don't want to just collect the data, you want to do something with that. And that's where the process of interpretation comes. But it needs to be done very carefully, because first, you need to know where the data come from, right? Because sometimes you're collecting a variety of bits and pieces of information from different sources. You might be aggregating things that can tilt things in misleading ways. So it's important to have some sense of how accurate, how, to the best of your knowledge, how representative it is, how was the data collected, so that you can know what it's reasonable or not to infer from it. Now, often in the process, before you can even talk about the interpretation of the data, you need to talk about its visualization, because for you, the data might be presented in ways that you cannot do anything with it, just because there is a plethora of stuff there that doesn't suggest anything one way or another. So there are different ways you can visualize the data, with pro and cons, each of them, because sometimes in presenting the data in a certain way, you may skew other bits of information. So it may be very helpful, for example, to have a pie chart, right, to consider the percentiles of certain groups. But this is not a very good way of providing exact numbers, right? You may have a bar graph, right, that's great to compare data sets, but not very helpful with establishing general trends. So those issues will factor in when you're considering the interpretation of the data as well, right? And finally, of course, having the data alone is not enough, in the sense that often, for the reasons I discussed, you may have a lot of correlations that are spurious. And to clean them up, you may actually need to devise tests to determine how certain bits of trends in the data are, to what extent these bits are representative and relevant, and what are not, right? So you need to do all of that before you can ask us, okay, now what do we make of the data? How can we interpret it, right? But of course, once you've done it, and we've done it carefully, of course, you can have a lot of very important and helpful information, right? Again, often it's not that the data would speak for itself. You need additional resources to organize, make sense, and identify trends in the data. And generally this requires additional data or additional reorganization of data. So it's an ongoing process that has some feedback loops as you go back and forth into the data. But that's a great question. Thanks a lot, Nita.
Thank you, Otavio. Once again, if you guys have any questions, please feel free to raise your questions. I'm also including the speakers from the panel. You may as well address each other with questions and comments. Now, Professor Douglas, yeah, that's your turn to provide your answer, of course. But just to make clear that you guys can also talk to each other. Thank you, Tom.
Thanks. Yeah, I have a question, but I'll start by answering the question to me about moral enhancement. So yeah, for those of you who don't know, moral enhancement is a term that's used to refer to the use of biomedical technologies to improve a person's moral functioning or moral virtue or morality on some sense of that term from an already kind of normal level. And I used to work on moral enhancement as well, like Professor Savulescu and Professor Persson. And actually the reason I got interested in this topic of use of neurointerventions in criminal justice was as in a kind of an extension of that. So when I was thinking about moral enhancement, everyone would always say, well, who would want to voluntarily moral enhance themselves? Not very many people. So the more interesting question is, would it ever be justified to impose moral enhancements on other people? And it seemed to me that criminal justice would be the context in which that would most plausibly be justified, given that we do, or you could argue that more traditional kinds of rehabilitation programs are already a kind of non-biomedical moral enhancement attempts to improve people's moral functioning. There are two reasons why I don't use the term moral enhancement anymore when talking about the criminal justice case. One is that you might think that the kinds of interventions I'm talking about are more like moral therapy than moral enhancement. They're trying to correct moral deficits or deficiencies rather than to improve moral functioning from an already normal level. At least some of them, I think, could be in that category, whereas many people think that enhancement is, by definition, something that's being used on people who are already normal with respect to the trait being enhanced. But actually, I think some of the interventions that might be used in criminal justice would qualify as enhancements, because they might just be, there's not necessarily anything abnormal about the offender. You might just want to make them, for example, more resilient to committing crime in a very crime-promoting environment which they live in, for example. So enhancing someone's resilience to crime-promoting environments could be the kind of thing that you'd want to do in criminal rehabilitation, then would be more like an enhancement than like a therapy. And then I guess the other reason that I avoid the term is that I want to be kind of neutral between different ways of thinking about the purposes of criminal rehabilitation. Some people think that criminal rehabilitation is all about sort of making offenders more moral people, but other people have a much thinner conception where it's just about preventing crime or improving social functioning in some less clearly normative sense. I think that people that have those kinds of views about criminal rehabilitation that don't want to think of it in a kind of moralized way should also consider the use of non-consensual neurointervention. So even though they wouldn't want to call them moral enhancements. Thanks.
Thank you. Did you have a question yourself?
Yeah, I had a question for Nicholas, which maybe I can ask. So when I was listening to your talk, I was thinking, with all the different arguments you were giving about value alignment, I was kind of thinking about how they would apply to humans as well as to AI systems. And it seems that we often have a problem of value alignment with, for example, our political leaders, where we elect someone to be president or prime minister, but then we have the problem of getting their values to actually be aligned with the public. And it's not straightforward to do that. And we also have, you mentioned the problem of people turning off, or AIs turning off the stop switch. You kind of have that problem with political leaders as well, when people like Vladimir Putin remove the term limits that would otherwise prevent them from staying in power. So that made me kind of wonder, like, to what extent are these issues new with AI or more severe with AI? Like which of the problems that you mentioned are kind of specific to AI, or at least more severe with AI, or are they kind of general problems? It's just that AI is potentially so much smarter than our political leaders at the moment that they could create more havoc if their values are not aligned.
Thank you for the question, Professor Thomas. So one of the interesting, I'm going to ask your first question with another question because, for example, like imagine that like you have like one of the ways that, for example, I approach the problem of value learning is imitation learning, like where like instead of me specifying a reward function for an agent to do, like it's going to learn a function to be optimized by watching the behavior of an expert. Like, I don't know, like imagine that like we have someone who acts accordingly to what we want, like a good driver, and you want to teach the driver, like, so like watch the policy that he's doing and like infer what is the function that he's trying to optimize. So, okay, that's good. Like, but like sometimes for some complex tasks, people are not optimizing just one function, they are optimizing many functions. So how do you aggregate that? And that's an open problem, and also in politics and voting theory and in moral philosophy. How do you aggregate different moral preference hierarchies? Like how do you aggregate different utility functions? How do you aggregate different moral theories? Like there is some promising work being done. Also, like I think there's a professor there in Oxford, which is William McCaskill. He has like his theory. It's called maximization of expected choice worthiness, which is a way of like combining like different moral theories. I like that. I use that on my work. Like it's good that you can build that on an algorithm and it works. But in the end, like for example, like in case of politics, it's interesting too, because like this is one of the problems of the voting paradox. Like you can have everyone like choose, like have their hierarchies of preferences well ordered, and when you aggregate them, like they don't represent like what anyone wanted, and that's a problem, and we don't know how to solve it. That the voting problem is an open problem in voting theory, and is also an open problem in like I don't know how the name of the area in English is, but like is the area of like social welfare or something like that. I don't know, but we have this problem, like we don't know how to aggregate that. So like even if we can align, even if we could like in a perfect world do this perfect alignment, in the end when we have to aggregate these preferences, we still gonna have something which is a mixed mashup, and like we still have like the challenge of like defining what will be the rules to aggregate different hierarchies of preferences. Because defining these rules to aggregate different hierarchy of preferences is a normative inference. It will not be just like an objective rule. It will be a normative one. So like the problem begins to be more complicated. And when I'm sorry, what was your other question? I'm sorry, I digressed.
Well, the main thing is which of the problems that you mentioned are specific to AI or more severe with AI?
Yeah, the corrigibility one. That's an interesting question. Like corrigibility is just one way of showing that like when we like I agree with Professor Julia, like intelligence is not defined, and I don't like the term artificial intelligence because like it's so ambiguous and misleading. But when we start to build systems that act smartly, like we get all of those nasty behaviors that come with intelligence. For example, like you tell me to do something and I will do exactly what you tell me to do, not what you wanted me to do. And like the problem also that like no one wants, like I have my goals and like I know my objective function, and like if you offer me a pill right now, or like if you wanted to open my head and like tell me like, oh, I'm gonna change what you want, I'm gonna say no, I don't want that. Like is the problem that we say is the Gandhi pill. Like imagine if we offer Gandhi a pill that if he took the pill he would become a psychopath and kill people and be really happy by killing people. Would Gandhi want to take the pill? Of course not. Gandhi would fight to not take that pill, because agents don't like to have their own reward function temper with. And that's true for people, and that's true for AI. AI is the one that, because it is not a question of like agency or nothing like that. Is the purely from an optimizing point of view, is because if you change my reward function, I won't get the reward that I want to get now. So changing my reward function, it's bad for my current objective, so I don't want to. And how do you solve that? I have no idea. This is an open problem. And people don't like to have their objectives temperate. Machines don't like to have their objectives temperate. And if I go further, like I'm gonna steal everyone's time, so I'm gonna finish here. And I want to make my question now.
Yes,
and I want to
ask
make
your question, Nicholas.
And I want to make my question to Professor Julia. I want to see if she can tell me where I can get those nice and fancy comic books, which I love the art, and if they are free. I don't know if they are free, and if they are translated for Portuguese, because
Yeah, awesome questions. Thank you. So I'm pasting a link to where all the comics live. Sorry, I should have done that earlier. There are two comic book series. One is only 2 volumes. It's the first one that you'll see at that link. It's called the Date Responsibly series. And one is complete. That series is We Are AI, and it has 5 volumes. We only have translations so far of the first volume of the Date Responsibly, and unfortunately not yet into Portuguese, but we would love some help with that. So in fact, the translations that we have are into French and Spanish. And the French translation was done by a dear friend and a colleague of mine who, by the name of Serge Abitboul, who is a French computer scientist and also is very engaged in social topics. And that translation picked up a lot more and had a lot more interest and attention, the French translation, because it was done by Serge, and then he knew the right people to send it to, than the Spanish one, although Spanish probably is a much broader, much more broadly spoken language. So if any of you were interested in working with us on these translations, please reach out. What we can do is we can even create a preliminary one, and then you could kind of put your, literary touch on it to make it a slightly different book. So all of that, of course, is in scope. And thank you for your interest. Everything is in the open source. Feel free to use the images with proper attribution. The details of that are in the comics.
Thank you very much, Professor.
Thanks.
Well, once again, thank you all. This was a great panel and so many interesting insights and great ideas to be shared with everyone. Once again, we'll move on with our event this afternoon. We will resume at 2 p.m. We have another roundtable, but let me take this time to thank again Professors Otavio Bueno, Tom Douglas, and Julia Stoyanovich, and our very good AI ethics researcher and AIRES-PUCRS president, Nicholas Kluge Correa. Thank you all, and have a nice day. See you around. Take care.
Bye. Thank you.
Bye.
Bye-bye.